Mm-mm. So can you see this now? Yeah. Yeah. Can you see this? Okay, super. Okay, super. Let me make it little. Yeah. I will do that something. Yeah? Problem. Mm-hmm. Because I just installed this software 10 minutes back, so that's why I was like not able to do the other changes, but it's that's good. Okay, so I hope you are now able to see this, correct? Is note one, no? Yeah. Hmm? Okay. Okay, good. So what happened here? So last time what we discussed, like total there were like four pairs of the points, total x and y, something like this. If you include that, if you include that, so there are total 8 points, like x, y including. So total 8 points. You have to store 8 bits or 8 pixels. But we don't have, we generally don't have just simply 8 points. There are like hundreds of points are there. Okay, so what we did, what we understood, like we don't need to store these many points. We can just simply store the some of the relationship between their 2 points. What is the relationship between these and their one of the coefficient? So what we called as this relationship as a representative. So representative is the relationship between these points. So what happened here, the representative is, because we understood that first point is half of the second, so 1 by 2 is the relationship, which is r of 2, because this is r of 2 because two values are there, and coefficients are the first value 1, 4, 2.5 and 3. 1, 4, 2.5 and 3. So these are the coefficient, and the representative is 1, 2. So this is 2 and this is 4. So here you save 2 plus 4 is 6. So you save, instead of 8, now you are storing only 6. So you are happy, like okay, I did that. But if it's a billions of data, like if it is billion x and billion y, because x and y you have to store, x comma y, point is always represented by x and y. So 100 billion times 1 billion times x, 1 billion times y. So here you need to store 2 billion, if it is a normal kind of storing things without any compression. So you need to store 2 billion data. And in second time, what happened, like if you go with this coefficient and representative way, you are just storing first representative, which is two value, 1 and 2, here 1 and 2, and the remaining only x value, only x, so that is 1 billion. So you are storing 1 billion plus 2, that much only data, means you are actually, instead of storing 2 billion, you are just storing 1 billion value. So that is 50% of compression you are achieving here. So you will be very much happy that okay, I achieved 50% of compression. Okay, that's very good that you started with a good thing now, like you are going ahead. But now we came to the point, like last time when we discussed, we come to the point like okay, if the given data, if if the given data is not falling on the line, if some data is here is fine, but one data is not falling, it's something outside, maybe consider this one as a x data. Okay, and this line, because as I mentioned, this 1 comma 2 is one line, for example here 1 comma 2, sorry for this, not exactly measurement is correct, but this is 1 comma 2 line, consider like this. So this is 1 comma 2 point, and you are drawing some line passing through origin through this point 1 comma 2. Okay, and if you just see here, what is this, this is maybe 2 comma 4, consider like this. But you are saying that 2 comma 4, how you represent, like it's a 2 into 1 comma 2, because 2 into 1 comma 2 is 2 comma 4, means you are just multiplying with some value, you say this one as a c. Okay, and 1 comma 2 is your vector w. Okay, this 1 comma 2 is w, and c is the scalar value. You are just saying that I am multiplying this value, so this point will be here, means you will say it's a c comma sorry, c dash comma w. Okay, this point will be another c dash comma w double dash, something like you don't know what is that, but it is like this way you can represent. You can say that c comma c into w. C is a scalar quantity, w is your vector. So you are saying like this. But now we understood that in the representation things, we understood that if the points are on the line, it's very good that you are able to achieve the compression. But the point is not on the line, so how we can achieve the compression? There is no chance to achieve the compression. So we are like now struggling here. I can't do this. So because we are the machine learning engineer, we have to find out some solution for that. So what we can do, okay, why can't we put this point, why can't we put this point somewhere on the line itself? Okay, you can put here, no problem. Okay, okay, you can also put here. Okay, you can put also here. Okay, you can also put this point here. But the problem is here, somebody like it's not like up to you that you want to put somewhere, because the problem already started. The point is not on the line. This is the main problem. So the problem is already started and you have to find out some solution for that. Okay, what is the solution? Okay, I will put, somebody say I will put here, here, here. But the point is, if you put here the point, if you put here, so the point is you are just giving this much of length, like extra length, that is called as error. You are adding this much point, this is error. You will, somebody say okay, I just want something like this. Okay, you can have this, no problem. Is maybe I will say e2 and this one is the error one. Somebody say okay, maybe I can have some other point here, so he will say e3. Okay, you can have it, no problem. And somebody say finally that okay, maybe I can have here only e4. It is something like starting like this. But the person said this is the error, this e1 e2 e3 e4 is the error, but I want the smallest error, I don't want the big error. Already the problem, I have so much big problem, I don't want like another error or another big problem with me. I want the smallest one which I can afford. Okay, you can afford the smallest one, which is nothing but this line. So this is actually the perpendicular line from the point to here. So we just discarded this point, this error and this error, and we are now going with this error, which is the smallest distance. So what is exactly the smallest distance? Smallest distance is the perpendicular line from the point on this line. So this is actually the smallest distance, which you called as a proxy. This is called as a proxy. So this point, this line is called as a proxy. And like you can say this is this point. So here this is some point here, and this what you can say proxy, and in technical terms you can say it's a error. This is a error. Okay, so you are saying that I am just putting this point on this line. So in future I am not going to see what are the other I'm not going to see this x and y. So I will just simply see only the proxies. Okay, in future what you will see, finally you will just see like this. So only the line. So you are not going to see this point. You will just see only the line. So once you see the line, you know how to optimize it by using the representative and coefficient, and sorry, representative and coefficient pair. You can just able to optimize this. Okay, and one second. Okay, so my daughter won't play with others if I'm at home, so she want to just come and play with me. Okay, that's okay. So what happened now here, we are just able to put all the points on the line here, and the line is now we are able to do the representation. But you will say that how we can put that, but what is this point? Is there any, because we have the value of x1 1 comma 2 here, some value, but what about this? Okay, we say this one as maybe c comma w. Okay, because as I mentioned, c is some kind of scalar value. You are just saying that you are just giving the information about okay, I just let me draw this okay, one, consider this. Okay, here, so this is 1 comma 2. So just it's a multiplication, it's just scaling the point. You are bringing this point. Okay, so what happened is nothing but you are just bringing this point, this 1 comma 2 point from here. Yeah, you are just bringing this 1 comma 2 point to here, means by multiplying this 1 comma 2 with some scaling value c, you are bringing it here. So you will say okay, that is c comma w, and what is this point x, which is nothing but x1 comma x2. Okay, so x1 x2 is now representing on this line. But how you will say that what is the value of this, because you will say c and w, but what is c? C should be some value, it should be some scalar value, you mentioned scalar value, but how you will find out the scalar value? Okay, so for getting the c value, because you now understood, like okay, I want to put the point which is outside of this line on this line, which is this x point I want to put here, and I am getting the c comma w. Okay, w I am anyway having w, because 1 comma 2 we have already, but we don't have c, means we need to find out what is c. So this is something what now actually the site of like the PCA will come something start here. So you need to figure out the C. So okay, so what we understood here, this is what the error, this is what the error, and you have to find out something like C is what, when C will come to the picture, C will come to the picture when this line fall down here. So means this, when you calculate something like this, then you will understand what is C. So once you say that this is the length of the error, this is what the error is, then you will see that okay, what is the C, and you understood like earlier that you need something minimum of this. So first of all we need to calculate the length of this C. So length is like the point here, this x, and this point here C, and w1 comma w2 and x1 comma x2. So this point, so you have to find out this length here. So we know this, our last time we learn this actual mathematics, how to calculate the length. So this is nothing but here, so x1 minus c and w, c and w1, one point is this one and another point is x2 minus c times w2. These are the coordinates. Okay, so you want to find out the length, means here how to find out length, x1 minus cw1 square plus x2 times cw2 length square, and because you need, this is actually the length which is nothing but in under root, this will come under square root of this. Okay, but the problem is you have to find out the length square, because what we are doing, we need to figure out the length of this, which should be minimum, and we are trying to find out length square of this error. And how we want, like okay, you can find out, but the point is you want the value of C. This is the, for example, wait a second, you want the value of the C which is here, not the C which is here. Okay, you want this minimum value. So minimum of C, you want to calculate the length of this error. Okay, why we are taking square, because we don't want this kind of a square root calculation at all, we just want a pure length of this. So you are saying I want to calculate the length square of this error, where the point of where the C is giving the minimum. So here you don't want this C, I want the C which is giving me the minimum of this value, minimum of the length square error. If you take here, it won't be minimum for this. So I want some C which gives the length square error minimum. So if you calculate, like finally what happened here, so like if this is the equation, and if you do the square of this, so you will just simply get so this is the equation, and if you do square, so what you get, I'm not doing complete calculation here. So here how you can get like a minimum of C, you need to find out the value where by using the C which will make it less, like there will be this C1, C2, C3, but you need to find out some C which gives this value less, minimum value of all the calculation. So if you figure out how you can calculate, you can just take a derivative of this with respect to W and equate to the 0, like dw by dx by dw equal, and then equal to 0, equate to 0, then you will get the final solution. So I'm not calculating that, but Here the final solution of the C is nothing but your x1 w1. This is something important for the exam point of view also. Okay, sometime the questions will come and you need to use this formula, x1 w1 and x2 w2 and this square. So you will say, okay, I got this and I understood that this is what the C value. Okay, so C, yeah, C is here, yeah, yeah. So yeah, I will just tell you this. I will just draw once again the graph so it will be easy for you to understand. See, I'm saying this is a x1 and this is some line what we are expecting to put the line here. Okay, and this is the points, the x1 comma x2 point or x point. Okay, and I am saying I want to put this point on this line. So you don't know where you want to put, maybe sometime you want to put here. So this is one type of C. Okay, you will go here also, you will say this will be the point, this will be maybe another C dash C2 dash. Okay, okay, something you will say I will also put here because this is here C3, or I will say C as of now. Okay, so this is C, C2 or C1. So which one you will take? You want to take the C, this C value which will which will give you the minimum distance. So you don't know now, because we are seeing in the graph, you are seeing in the picture, so you are seeing that okay sir, this C is very good because it's very near, but while calculation you can't see it because you have hundreds of data, you don't know. So what you need to do first, you need to calculate the distance between this point and this point. Like you need to calculate this distance, okay, we call this distance as error 1. Okay, you need to calculate also this distance, too, here error 2, and you need to calculate this distance also, this is error 3. Okay, you need to find out which is the best distance. You don't know, like this is the graph, that's why you are able to see it, but you don't know. So that's why what we are doing, we are actually, this W is like, you know that because this W is 1 comma 2, we already got that 1, and this is the 2, this W is 1 comma 2, for example I am saying, which we can say W1 into W2, W1 comma W2. So we have already W1 W2, but we don't know C. We have three options, C1 C2 or maybe this is C3. We have three options, C1 C2 C3. You don't know which C is the best one, but how we say that which is the best one? We'll say that okay, this is the length square. What we need to do, length square of the error, we need to find out this value. Length square is that x1 minus C W1, because this is C or this is C, maybe C1 W1. Okay, because W1 why I am taking, because this all the points are multiple of W1 and W2. Okay, and next one is your, this is square because we are doing length square, and x2 minus C1 W1. Okay, here W1. Okay, so we are just finding this value, or you need to find out maybe x1 minus C2 W1 plus x2 minus C2 W1, because all are here, or you need to find out x1 minus C3 W1 plus x2 minus C3 W1. Then what happened here, you will find out this value, this value, this value, but which one you will take, which is the minimum value, whether it's for example this is A, this is B, and this is C. Which one you will choose, which is the minimum between this A, B, C. So you find out A is less than B, less than C. So what happened, A is the minimum value, which is nothing but this value. Okay, A is the minimum value, means you will choose C1 dash here. So this is like C1 dash, C2 and C3. So you will choose this C1 dash here, which give you minimum A. So x1 and W1 is a constant here, x1 is constant, x1 is same, W1 is same, W1 same, here same. Only what is the change here, this C1, C2, C3, this is changing, means you need to figure out the C which give you the minimum value of this equation, length square error equation. You need to find out that c value which give the minimum. So you have already calculated c1, c2 and c3 this value. Using this c1, c2, c3 you calculate the error c1, c2 and c3, and you find out c1's error. The error comes with c1. When you use c1, the length square error is a value, and then b value and c value, and the minimum of that value, minimum of the abc is the a. Means because of c1 I am getting a, so you are trying to find out minimum value of c by which you are getting this length error, by which you are getting this length error is the minimum value, trying to get the c value which makes the length square error minimum of other values. So you are trying to find out the c. So that's why, though it's a single value, but we have the options of c1, c2, sorry, c1, c2 and this c3. So we have three options, or we have maybe many options. Like you have, maybe there is another options here, c4, you don't know. So you have to just simply calculate this also, but you have to find out minimum value of c which gives you, or you have to find out the value of a c which give the minimum of this value, minimum of length square error. I need to find out some value. I need to find out c which will make this equation minimum of other. So this is what the actual c is here. Let me hmm. So in exam what they will do, like they will ask you like find out the proxy, what is the value. So you understood that now, like you now know that what is c is what now we concluded, but before that ma'am has asked the question. She is satisfied with that, or she is still having the doubt? Okay, so what happened here? So in exam what will happen, like they will give some question, but you have to find out c. So how you will find out c? This equation what we derived after the calculation, x1 w1 x2 w2 divided by w1 square plus w2 square. So this is the way how you will see where is the c value, which is the best c value. So we started with the some equation, and that equation help us to get the c value. So anyway you have w1 w2 in the, like you will get the w1 w2 value, and you will have x1 and x2. Then you have to figure out what is the best c. So you will, like you will get c1 here, this c1. So this is the way how you will understood the point, which is a following. So let me draw this here in the graph. Yes. But this is, I'm we are not now at the PCA. We are just on the path, like we are going towards PCA. So PCA is algorithm is something now not started, but this is the idea we are going towards that. So if you understood that what is a proxy, why we started with the proxy, because we understood that okay, it's all points are here, we are happy, but some point is behind here. So we don't want the point here, because we know that if we represent the line and we say that okay, this line is something here, and we are able to represent the all the points by using the representative plus coefficient, and then we can achieve this 50% of, like 1 billion data. So we can achieve 50% of compression. This is very good. But when it is good, when all the points are on the line. But if some point is here, so what you do? So what we understood, like if some point is outside, so what we can do is we can just simply put the perpendicular length, that is called as a projection. So we put this point on this line and forget about this point now. So this point is now here, okay, and so this point is now here. And in future what happened, like you are just now calculating, you are just saying that okay, there is nothing here, I am just now able to see only the points. And you can see these lines here, this proxy only help you to get the results. your normal points which are already on the line, that is not, that is like okay, they are already following the line equation. But the proxies which you put, like I'm just giving one example, but maybe there are like thousands of other proxy values. And in real data, never it happens like your all points are falling on the line. You in real data, what happen, you are something like here, here, so many datas. So you have to deal with the proxies. So you are saying that okay, these are my datas. So what is the best representation I can do? It something like, maybe you can say that okay, I can draw some line like this. So that something like this data I'm just drawing here. So how this data can be represented? Okay, let's draw one line. Try to draw some line here, and you say okay, this looks better because it actually going through the points and the points are very much near. So I'm happy with that. So how you are happy? Because you are, every time you are just representing this, so you are just putting one proxy line here, you are just putting the projection of the lines here, this point is already here. This is a real time, not like theoretically what we understood, like taking all the points on the line and just single point. That is okay for the understanding the concept. But generally when you take hundreds of data from Excel sheet and see that the data will be something like this, so you have to put the proxies, you have to finally put something like these proxies on the line and say that okay, this is the what now the line looks like, because the lines will have the proxy values something like this here. So real time something will be something this way you will see the line. So maybe in future, like our final output is something this line with all the points here. So you, for example, you just earlier the points were like in the cloud something here, but now the points are on the line, because these points are nothing but the proxy, and that proxy will help you in the compression. So how you got the proxy? So this proxy is nothing but, so as I mentioned, this point, okay, this point is C into W1 W2, okay, this point, because we know that C is something which is scalar value, which is just multiplying W1 W2 to make it this point. Okay, we got C is what, x1, C is what here I have just mentioned, x1 W1, x2 W2, and this one. So what we understood now, okay, so C is here, x1 W1, x2 W2 divided by W1 square and W2 square. Okay, so this is C. What we understood, see, x1 W1 is what, we have already this point here, this x point is x1 comma x2. So if you just simply calculate x comma w, that is x transpose w, x transpose, like, or w transpose, you can say the same. Okay, so you will get this numerator value, correct, this x1 x2 w1 w2, if you just multiply x1 w1 plus x2 w2, that what you are seeing here. Okay, this is just the inner product of x1 w1 and x1 x2 and w1 w2. This is just a simple inner product, because if you do this kind of inner product, then you will get this. And what is w1 w2? No, the numerator is not a scalar value, because these are actually x1 w1. So here you will get some kind of a matrix. So this is like 1 comma 2 or 2 comma 2 for example, 2 comma 2 matrix. So sorry, this is what the actual scalar value, here also scalar value, but this is something like an inner product, this one. So final is this is a scalar value, this C is the scalar value final. Okay, so here we understood that the above numerator is the inner product, the numerator what we understood is the inner product of x and w. But what is w and w2? W1 and W2, you now from this graph we understood that W1 and W2 is some value which is like I mentioned here, like w1 is w1 and w2. So these are the some value which it was having some x and y value, which is something here, but you are seeing it here, it is in the denominator. And if something is denominator, the problem will start, like it is trying to scale the value. It is saying that if you say 5 you will be happy, but if you say 5 by 2 it will be 2.5. Oh, it is reducing, means this value has the tendency of reducing this x1 w1 x2 w2. So it's better if we can make it like equal to 1, w1 square plus w2 square equal to 1. If you do that 1, if you consider like 1 in your case, like if you consider this is like 1, then it is helpful for calculating the next things like the variance or eigenvalue and all. It's very helpful. So for that reason, what happened, we will say that what w1 w2, like this is nothing but what, if you calculate length of w1 w length square, that is actually the length square of your w1 and w2. If you do this length square of w1 w2, you will get this. So that is actually length square. So you are saying that I want to take w1 square plus w2 square equal to 1, means you are just controlling, or you are just trying to get w1 and w2 in that, because you will say, you know that x square plus y square equal to a square, it is a equation of a circle. So something like here, I am saying that I want w1 and w2's equation, like this one should be here on the circle. It should not be outside the circle and inside, it should be on the circle. So I want some points of w1 and w2 which should be in the unit circle. These are the unit circle. This is something like, see, in exam point of view, you just need to remember the equation or remember the formula. But what is that w1 w2, you should know. Like if in future if you are somebody asking you explain this basic of algorithms and also, you should know what is w1 w2 square and why you are not taking this. So these kind of things I am just explaining. So for example point of view, you will say, okay, I know c equal to x1 w1 or c equal to x into w divided by w square. So that's okay. But in this point of view, exam point of view, is very useful to know the formula. But if for interview point of view and all, if you are saying that I'm machine learning engineer, know the basic of all the machine learning algorithms, so better to know these kind of concepts for you. So we are considering only the unit circles to make sure that it is not affecting on the complete equation. It is not, should not affect on the equation. So we are taking that w1 square plus w2 square equal to 1. That is nothing but a unit circle. So this is something 1 w, another w, here w, w, w. So this is giving you the directions, like see these directions. But these directions you are just taking, and this value should be 1. w1 square plus w2 square should be 1. So you are just checking the points on the unit circle. So you are just controlling it, so you will just properly get x1 w1 and x2 w2, this c value here. Okay, so I understood now I understood that, okay, there is one point outside the line and I'm just projecting the point on the line, and the line point is nothing but c comma w, and in that c, this c comma w, I got c value which is x1 w1 x2 w2 w1 square plus w2 square equal to, and this one into your w. So here I will just draw it. Okay, c is equal to x comma w divided by, as I mentioned, this is the length of w1 w2 will be w1 square plus w2 square, which we consider 1. So that is what length of w1 means, this one, length square of this value. So this is actually here, I am just saying that this is here, and x1 and x1 x2 and w1 w2. So we just cannot simply say that x1 x2 w1, this is like the inner product, but we say like this, x1 transpose w and divided by w square. This is what the c, and the point is what, because we say that this point is what, c into w. So we got c. So this point I am saying this point is, c is what, x transpose w divided by w square into, because we have to take this w also, so this is nothing but w1 into w2. Okay, this is what, this point. x transpose w, x transpose w divided by w square into w1 comma w2. So till now anyone has any, because now we are going to next point, but this is something you should like just remember the formula, but you should know how we derived it a little bit, because without math if I say c is equal to xt w x transpose w, and this you will not understand in the future, because the classes the sir's video has this kind of explanation, but maybe if you forget it, or if you just lose the interest in listening that, then you will not get how the formula, and you won't remember also the formula. So better you should know how we understood this. So any doubt till now? So if you have any question, any doubt, we can just solve it, or we'll just go to the next point here. So should I go to the next point now? So this, because this algorithm is if I just simply give you the math, then you will not get what exactly this algorithm I'm saying. Like without math you will say okay, there is some value and PCA is very easy, but in interview point of view, if you say that I am just using PCA, but the PCA generally used in the face detection. Okay, if you go with the face detection kind of algorithm, where the if your office is having some camera system to detect the face, so that time you can use the PCA algorithm. So that's why if you are trying to implement this algorithm by yourself, so you should know what is the PCA. And before that, if somebody asks why you started with PCA, why you are, then you have to say that okay, if the point is on the line, then it's okay, but if the point is outside, how you are calculating it, how you do the proxy, how you do projecting the point on the line, and once it is on the line, then you can calculate the representative and coefficient, that you can compress it. But that's fine, but what is that if the point is on the line, how you say that this point is on that line, which is the best point? So which is the best line, because we have so many lines, so that part will now start. Okay, so just remember this equation here. Okay, just remember this equation. Anyway, we will come to once again this equation, but just remember as of now this one. Okay, so yeah, any graph here, I will draw this. So okay, so these were earlier, these were the points, you were happy with that, you are saying that's very good, but the problem started with the point here, which is x point, you don't know. And this line is represented by, this line is represented by w1 comma w2. You know that w1 w2 is, for example, 1 comma 2, 1 comma 2. So this is 1, this is 2, and this is line. So you are just saying that some line passing through 1 comma 2 through origin. So this is the line what I am just drawing here. This is the line 1 comma 2. So if you say 2 comma 4, it is just scaling of 1 comma 2, c comma w, c is any value. Okay, so you are just drawing this line, and you are now saying this is the x, this point I want to put it here, it's nothing but here, this point. So you are now saying this is the point, I am happy now. So this is the point, this is called as a projection of x on this line, and this point is called as c comma w, this point here. So what is c? C is nothing but your x w, x transpose w divided by your w square, and w is what? W1 w2. That is what this point. So this graph looks like this. This is the smallest graph I'm just plotting. So is this the same, is this answered your question, or now we are going towards PCA, we are going towards PCA, it is on the way, like I'm making you ready for the PCA. So this is something in PCA, if I say something like this, and you will say okay, I got the answer, that's fine, but how you come to that point? If I say this is eigenvalue, so you will say how this is eigenvalue, what is this eigenvalue? You only know that eigenvalue calculation by decomposing, like scalar decomposition of this matrix. You will say that okay, I am very much happy, I got eigenvalue. But what is this eigenvalue in PCA, what it is doing in the eigenvalue? So we are coming to that point, why we are calculating the things with the eigenvalue in the PCA algorithm. So we are going towards that. Okay, so you are just, I'm just making you ready in your mind, like okay, we are preparing for the PCA. So this is how we are going towards the PCA. So see, this graph, I just plotted the graph, and I mentioned like okay, these points are on the line, but there are like generally in actual workflow or in the day-to-day life, if you get some CSV data, Excel sheet data, you will not simply get all the points on the line. The points are something falling somewhere here, like you are plotting the point x and y coordinates, and you are mostly the points are here. So what this line is showing, this line is showing that your points are this direction. If the points will be something like this, so you will plot like this, so your points are this direction. Okay, and if the points are something like this, so you will say already x line is here, so your points are this direction. So you are considering this is the direction. So what is direction? If you understood the direction, that is what we are now going towards. That the direction is nothing but the variance. This is the variance. And what is the variance? What is the variance? The variance is nothing but, here the concept of eigenvalue comes. This is nothing but the lambda, that is your eigenvalue. So in general, one second, let me close the door. So in general, you are saying you will do the calculation of in mathematics, you will have some for matrix and all. So you will say I am calculating eigenvalue and eigenvector, but in technically background you are saying that the I am calculating something which shows me where these points are actually mostly crowded. So mostly the points are crowded in this direction. So this is the logic behind it. In MLF we have calculated this matrix and all, eigenvalues and all, but actual reason is, if you actually see what was the eigenvalue and eigenvectors, these are helping us to tell us where is exactly the impact of the points more. Like here the variance is minus negative, here this graph the variance is negative. It's saying that negative means what? Mostly the points are like this. They plotted the points are something like this in the graph. If you have 1000 points, if you see that they will show that their trend is down. If you have 1000 points, you just simply plotted on x line or the axis, the trend is here, like this direction. If you plotted the graph in this way, the trend is this, and they're trending up. What will say that there are some algorithm on the on some website, they will say that there is this particular topic is trending now, it is not trending. So what they will do, they will see that how many discussions are happening on the point on that about that topic. So they will plot the graph of that, and they will see that maximum discussions are happening on this, like on something like maybe maybe AI. The maximum discussion is happening on AI and robotics and all. So they will plot the discussion points with some x and y axis, like x is maybe the area or like the India, and y is like people discussing on different topics, and like something AI related topic, how many people in India are discussing. So they will plot like this, and they will see that most of the people are discussing about AI, so the trend is showing like this. So you say, oh, there is a trend, but what is trend? That is the variance. They are internally calculating. So what machine learning engineers do, they will get lots of data, they will plot the data, and they will see which direction this data, maximum data is from. Like if I plot like this graph, the graph, like the line like this, but that line is not helpful because the line is not giving me anything about this information, like whatever this information. So it is not showing me any trend. So the trend is showing by this line. So what you are doing, you are indirectly calculating the eigenvalue of that, and which is the maximum eigenvalue. Corresponding to that maximum eigenvalue, the eigenvectors you are calculating. Eigenvector will show you this direction. And what is that eigenvector? This eigenvector is responsible because of this lambda. This is eigenvalue. This eigenvalue say, okay, I am the maximum eigenvalue of this data. You are calculating some matrix, covariance matrix. We are come to that point. We will come to that point, but I am saying firstly, you are calculating the lambda, and corresponding to that, you are calculating eigenvector, and then this eigenvector will say you that which direction is the trend going on, and that direction is nothing but, you will then say that okay, trend is on xy subject and all. So internally you are doing this algorithm. If you see, if you go down deep into that, so they are doing this kind of eigenvalue and eigenvector calculation, and this will help you to get the trend of the data. So the data is, the trending is upward, or the trending is downward, or the trending is something like neutral, it's not like too much, it's okay, something like this. So this is what the variance, like variance is like how popular your things are there, how crowded the things are there here, this direction. So this is what the variance you are calculating, and variance is nothing but your lambda. So we'll come to that point, but I just like giving you the like what exactly this PCA will give you, that is what you are able to find out the trend. So I will also try to give you one example. I yesterday created one Python file to give you the example of how the PCA will help, and then you will understand more into that. If you will actually get the feeling of the PCA algorithm in your machine learning things, like how we can use the PCA for face detection. So there we will go with that. But yeah, first of all, just I hope you understood that you have lots of points, and you projected all the points on the line, and you are now able to say that you are now able to represent that complete data set with the combination of representative and coefficient, and you are getting the data set, and you are able to represent it with the compression. So that's very good with the PCA. But till now, did you have any issues, another questions? So if not, then we'll go to the next point. Okay, so the next point, because as I have already mentioned that um, that we have this line, because every time I'm saying I'm having this line and all, this line, but next point you will say, so this line is good, or which other lines are anyway, because see here these are the data points, some data will be here. So I will say this one as a L1 line. Okay, so I will plot my proxies here, my projections of the points, I am plotting it here. Okay, something like this. So you will say maximum points are something like this. I'm just not drawing all the points. We are going towards that. Okay, and this is under 1.3, the point what I am just explained. The week 1.3 point was what I have explained you that. So I'm not telling anything outside that, but it's a week 1.3 points. Okay, and if you just understood this one, you don't need to also go to the videos. You just simply start your once you get these questions, you can start your answering it, your graded assignments. No need to go through the video, because these videos are covered in this lecture. So okay, so I have already projected the point. So I am saying that okay, this is some line I am projecting. Okay, but this line I said that this is the L1 line, and in the next point, okay, consider this is height and width. Okay, height versus width graph, like height versus not width, it's a weight, height and weight. Okay, height and weight. So you will say that the height of a person is x and weight is something y, because you know that if somebody is very heighted, very tall, then he has more weight or something. So this equation we are just drawing like this. Okay, so their relationship is something like this. So but the next person comes and he say that no, I don't like L1 line, can we draw L2, something like this here, can we draw something L2 here? Okay, you can draw, no problem, you can happily draw. Then you just project all the points on this line also. He is happy with this, he is happy, he is happy, so he has to draw all the proxies here, or the perpendicular line, okay, all the proxies here. So everyone has to draw, because you either will choose L1 or you either will choose L2 line, so it depends like which one. But if you actually see the lines L1 and L2, the problem is because you don't know which L1 is good or L2 is good. So L1 is good or L2 is good, this is a problem, and we need to solve the problem by, so first of all, you understood that we have, so I just draw L1 and L2. Did you understand that we have L1, L2, L3, L4, L5 number of lines, correct? But we have to choose which is the best line, which is the best line which will give the, which will give the this equation. So I have L1 and L2, but which is the best line? Okay, so the best line is, the best line is nothing but you have to find out, because as we have discussed, like this is the error, as we have earlier discussed, this is the error, this is also error, this is here, so this is one more error, okay, this is error, these are the error, okay, these are the errors. So we know that these are the errors. So if you just sum up the error, like this is maybe E1, E2, E3, E4, E5, E6, maybe En, okay. So you are just summing the error E1, E2, E3, E4, E5, maybe there are E100 points are there, for example, okay. There are 100 errors, okay, just you are just summing that. And for this is for L1 you are doing. For L2, because L2 also having these proxy lines here, so you are just also doing L2, L2's E1 E2 dash, like L2 E1 dash for L2, okay, and this is for L1, E1 dash, E2 dash, E3 dash, E4 dash, E5 dash, and so on till E10, E100 dash. So you are just calculating all the errors here. You are calculating L1, N1 errors, L2 errors, and you are trying to get the errors which is the minimum one. So you are trying to get, so these are the, this is called the errors. So you are trying to figure out the error, or you are trying to figure out the line which gives less error. So should I go with L1, because the error with L1 is this much, maybe X, so not X, A and something, A value, and with L2 it's also B. So you are trying to get the line which gives you the minimum error, the same way as last time we discussed na. So the point is something, last time we say that this, whether C should be on here or whether here or here, so we say that C should be here because it gives the minimum error. So error is something is always with us throughout the MLT subject. So error is every time with us. So this is the minimum error we should get. So once you say that this point is projected here, that is okay, but I am not confident that whether this line is good or this line is good, or some other this line will be good, or something this line will be good. So I am not confident in that. Okay, no worry. So here also we'll also go with our error concept. Error is nothing but the line, this is like a reconstruction error, these are the errors. So the line which give us the minimum or less reconstruction error, that line is the best line. So the L1 is giving minimum or L2. So from this graph we can see that maybe because the proxy lengths, these are the small lengths compared to the, because the same proxy here for this something like a bigger length, but the same point will give you the minimum length here. So the proxy, if you sum something like sum of all the these projections, so that we projections or error, if we sum this one, if it gives minimum value, then this is the best line, L1 is the best line instead of L2. So now here we can go with the L1 line instead of the L2 line. But you need to understand like how we can, because in the real time, as I mentioned that in real time the data won't be on the line, the data will be something scattered here, and you have to plot the line. You have to figure out L1 line is better or L2 line is better. That because you are now seeing in the workbook, or you are seeing in on the screen, that's why you can able to see that L1 and L2 line. But if you have Excel sheet data, if you have something like a big image, it's an image of one thing like 192 by 168, one person is happily giving his photo, Okay, so you are seeing this kind of image, but this image is like every pixel value. So these are the pixel value. So this pixel value you are something like plotting here, and you are now figuring out where the trend is going. Like trend is nothing but which is the maximum, like maximum feature along this direction. Or if I plot here, I can't see any person here. Like if I just plot the xy here, okay, if I plot the xy for this picture, so if I just say that this line, so I cannot see because the person is here. So most of the information is in this quadrant, and most you feel that the points are something like this here, like this. So most of the information is here, so the trend will go in this direction. The variance or the maximum information lies in this direction instead of this direction. So this way you need to find out whether should I go here. If I draw here, no, I'm not getting anything here in this quadrant also. Okay, if I draw here, I will get very less information. If I draw more here, so I will get hand, face, this some part of body here, this one. So I'm getting more information in this direction. So you have to figure out which is the best line can represent where is the data, like where is actually the object is there, or where is the maximum information about this image present in your photo. So sometimes we calculate the histogram, and also histogram draw something like bell curve. So they will say that maximum informations, like this is something different concept, but it's like more of the information available in which region. But histogram is not exactly the same way, but I'm saying one of the point is like if you draw the line, you have to get where exactly the maximum information stored on the image. So this L1 and L2 are the lines, and you are trying to figure out the line. So I will just say that what is our goal. Our goal is find the line which gives you less reconstruction error. Okay, here these are the reconstruction error, E1, E2 or E1 dash. So I have to find out the line which gives me this reconstruction is what, this E1, this proxy length. So sum of all the proxy lengths, if I do the summation of all the proxy lengths, so you will see that what is the reconstruction, what is the actually the length of the one line, and then you will calculate for all the proxies. If I have 100 data, I will do the 100 data projection on that L1 and as well as on the L2, and I will do the summation of all the lines, and then I will see that okay, this sum of L1 is less than sum of L2, the projections, and I will say that L1 is the better line, and I will just follow the same line. So maybe I won't go deep into that calculation, but just the point is like how this error, because as I mentioned, this is error of the line and the data set, because you have to find out the data set, you have to find out this line and every point here. So these are the data set. So you have to find out the error between this line and the data set. Okay, so because now you don't know where is the line, because you can't see the line. So how we can say this is line? There is an equation here, because you know that the data set is, the data is what, for example, data set, you have data set of x1, okay, x1, x2, x3. So consider this is something individual data points, okay, in xn. So this x belongs to what, this is rd, like you can say that one person, x1 is maybe Murli. Okay, Murli, don't think take it personally, okay, just because I remembered your name more, so I'm using this one. Okay, so Murli has the information about his height, weight and age, for example. Okay, so these are the age, x, height and weight, and age is nothing but your how many values you are storing. So d is what, d is saying that d1 is your height, d2, d3, so you are in r3. Okay, so how many are there, something like Murli, next is Ashwin is x2, same way height, width and age. Okay, same way we are having x1, x2, x3, and we are each one is having their own values here, height, width and age, here height, width and age. So we represent this one as an RD. So RD is like D may be 1 or 2 or 3, in this case is 3. So like this, okay, we have the data set like this, and you are saying that we need to calculate the error of the point and the line. So what we did, like, you know that this is x, and this is something like line, we say that, and we say that this is this line is nothing but c comma w, and this is the x, this is the error. So we have to find out this error, and this error is nothing but, so here, so once again, because length is what, length square is nothing but this point x, and this cw, because this is the line length, so this point and this point. So this c is what, and we know that c we have calculated last time, x transpose w divided by w square, but as we know that w square is 1, we consider this as a unit circle, so we consider this equal to 1, so no need to write here, into this w. So what, x, this x minus this cw is what, this one, x transpose w into w. So we will not go detail into that. So this is what the error says, okay, this is what the error give us. So if you because I can just go mathematically here, okay, let's maybe 3-4 steps are there, so uh, don't take it more seriously this one, but better you can know that this is like some mathematics is behind that, you should know that this point, okay. So I can maybe tell you the formula, end formula, but that won't be helpful for you. So just simply understand this. So what is that, this length is what, x minus x transpose w, because see, x minus x, this is the length, okay, into w, length square, okay, and you are just doing the summation, like summation, I just don't want just single, I want here also, I want this length also, and I want this error also, I want to sum all these things. So that's why summation of I equal to 1 to n. Why n? Because there are n points, there are 100 points, n is equal to 100, so you are just doing summation of all the proxies. So, and you are just calculating length, so it should be square of that, because length will come thing like under root, so we don't want under root, so we are doing the square of this. So you are trying to get this calculation, and how you are saying that I just want the minimum of that, I want the minimum of this value, I want the value x minus x transpose w, this all the summation value should be minimum, okay. So earlier we saw that I want the point, okay, the point which gives a minimum of c, we understood that minimum of c, like you want the point which gives the last what we discuss here. So we consider minimum of c here. So sorry, where is that, here minimum c, we consider this error square with the minimum. So you are calculating length square error, the c value which gives the minimum of the length square error, so we are doing here this way. But same way here, you are trying to do minimum of some value, or we say that w, minimum of w, you are trying to get the minimum of this. How you will get this? By using this w. So because as I mentioned, in this unit circle, one direction is this one, this. So what we get, yes, yeah, so what we get here, we get the direction, which direction we should take, this direction, L1, yes, we get the direction L2, L3, which one is the best direction we will get. So if you solve this one, yes, so we'll get the best w. So w is what I mentioned last time, it's a 1 comma 2, correct, this w, as I gave last time the information, this w is what, w1 comma w2, so this is 1 w1, okay. So you need to find out the w which gives you the best direction. So here we are getting the best direction. So earlier we know that, okay, I am getting the best proxy, but you said proxy is fine, but now the next point is, should I plot on L1 or should I plot on L2? Should I go with this L1 or L2? Should I plot here or should I plot this L2 line here? So now you have to say that should I go with this W1 or should I go with this W1 or W2? Should I go with W1 or W2? Like, should I go with this line or should I go with this line? So to find out which is the best one, you are now calculating the W. And once you get W, then you will be happily put that okay, I am happy with this W and I can see the trend is this way instead of this way, this trend instead of the other trend. I can see the best trend is the green line and not the red line. But this green line trend is what? W, calculating the W. So you are saying that I want a W direction, I want a direction of W which gives me the maximum variance or which give me the trend. I will say as of now trend because we are not coming to the point of variance. But so instead of calculation doing the more calculation, I will give you the final formula here. So as I mentioned, like here this length, you are calculating the length, this length, you are calculating this length, and you are doing sum for all. You are doing this length calculation, sum for everything. So that's why this summation. So length means what? This length is nothing but error, so this error, okay, and you are doing the length square, so that's why square, and you are just doing summation of everything. And so here, like if you do the calculation like what if I just solve this, like because it's x square, so x minus x transpose W and W square, if I just actually solve it, so you will get like the solution is there in the video. But if you are interested, you can just maybe check. We can also do it here, but then maybe you will should I do it? Maybe it's a two lines. Should I do it, or what do you think? Should I do the solution? Yes, yes, yes. Yes, yeah. In the first point, what we did, whether we should plot it here or somewhere out, so we decided we should plot it here. Okay, like perpendicular distance. We decided in the first equation, first time we decided, and we understood C is equal to X transpose W divided by W square into this is what C, and if you want this actual this point, it is nothing but C into W. So into W1. So this is what the C value, okay, and this point is C into W. So if you just multiply W1 W2, you will get this point. So in the first we understood this one. In some video 1.4 video you understood this one. Now next video is 1.5, what the week video is there. So now they said that okay, you understood this one is very good, but how you say that this L1 is good? Because you can maybe plot on L2 also, you can maybe plot here also, you can maybe plot here and L2 will also give the proxy and representation and coefficient. It will also compress the data, it will also compress the same data L1 L2, because you are finally what happened, you are just what you want, you just don't want any point outside in the space. You want everything should be on the line, any line, L1 line or L2 line, any line is okay for you, because once you plot everything on the line, you will say that okay, I can use now my idea of a representative plus coefficient. I can use that idea and compress the data, represent the data in smaller info with a smaller information. It's okay, but which one is the best line, L1 or L2? Then for that reason you have to find out the direction of W. You have to find out which W is the best one. Should I go with this direction or should I go with this direction? So that is what the important thing you have to find out in the next point. But maybe we don't go in the deep into that, but I will just finally give the equation of this. So what we do, we have to solve the equation. Okay, this is max of, okay, first of all I will say 1 by n summation of I equal to 1 to n xi transpose W whole square. Okay, and you have to do the average of this, because the average is something, if you do, if you find out this line is trending, if you just scale this, you can say like okay, you can simply say instead of the bigger line, you will say that okay, this line is also showing the same. This line will also show the same, like the smaller line. The bigger line is also showing the same trend, the smaller line is showing the, so means doing the average is not a problem, like you are just scaling it also is fine. So this is what the you are trying to figure out the maximum. If I just solve it now, so you will understand, because this is a we need to find out the minimum of w, and that how this converted to maximum formula. I thought that to solve it, uh, to just see for two steps, because then you will understand how the minimum converted to max, because then only you will feel that okay, how the w started here, and how we got the max to min value. So to okay, before doing this, I will ask you one question. For example, um, so how you can say that I have something like uh, okay, instead of this I will say okay, what happened? Can you draw anything? Wait. Oh, sorry. Okay. So what happened now? Instead of you are saying I am just minimizing this value, I am just minimizing minus f of x value. If it is minimizing minus f of x, minus of minus means what you are doing is plus, means what you are minimizing of this value means you are indirectly maximizing the value, maximizing the f of x instead of minus of f of x. So this is what you are minimizing negative value means you are maximizing that actually that value. So this concept is important while deriving the point here. So you are minimizing did you get that what is exactly what we are what I'm trying to say? If you are minimizing some minus f of x value, or you are minimizing some x into w, or you are minimizing something like minus 3 comma 2, what is that, minus 6, what it will do, you are minimizing means what, minus 6 minimization is what, minus 5, because you are not going deep, minus 7 you are not going deep, you are doing minus 4, minus 3, minus 2, minus 1, 0 means what you are doing, you are increasing that, you are maximizing it indirectly. So that is what here maximization. So minimization of minus f of x is nothing but maximization of actually the minus as maximization of that value instead of minimizing this. So this is what the concept. But this concept helpful for you while solving this equation. So to okay, if I just say you, like if I just because as I have mentioned you, so what we are doing here, x minus, okay sorry, xi minus xi transpose w, this is what the point into w, and this is what the square, and you are just doing the summation of that. Okay, this is nothing but something like some function of f of w. Okay, so as I mentioned that you are just getting the trend, if you scale it also it's fine, if you do average also it's fine. So this is what here. Okay, so this is two steps next, but it will be helpful for you how these things will come. So here what happened, you need to minimize that error. Okay, you need to get the error, this error, as I mentioned you are getting so many proxies, you want to find out all the proxies summation, and you want the summation which is the minimum, whether L1 is minimum or L2's proxies are minimum. So you have to find out that. So if you just calculate it, you will get f of w equal to 1 over n. I am just giving the the formula here, I is equal to 1 to n. If you, because it's a square, this is square, so if you just solve it, you just try to remove the square, so you will get the final equation is something xi transpose into xi minus xi transpose w whole square, this is the bracket. Okay, this is the solution what you get if you solve this. But you will see that because we are interested into w, you want to find out the w value which gives you the minimum, so you don't need this because there is no w point here. So this is a, maybe something like a constant for this, constant value for this. So if you drop this one also, you don't have any problem. So because this is f of w, so I am just going with the new equation by dropping this value. So g of w is 1 by n summation of I equal to 1 minus xi transpose w whole square. So this is what you get, and what you need to do, you need to minimize this, for some value of w, because this is, you need to minimize this equation by using some value of w. Should I use this w or should I use this w? You have to find out the w value which minimize this complete equation. So g of w is minimizing 1 by n. Maybe this one is not helpful for the exam point of view, but it's better to know this, what exactly this equation. Okay, and as what it is doing, minimizing this, but what, by using what, this w. You have to figure out which w is minimizing this equation, means which line indirectly you are seeing. Yes, yeah, but this is something, if you go with the problem, yeah, you will get the vectors value, but if you see the big picture, maybe it's like a smaller picture in the complete big algorithm. But if you actually go with, like, somebody asks you, can you calculate the proxies and all, if you, they will give you the something like a table of points, x y coordinate and all. So there you will get all the w values also. So then you will take the value, help of the w's, or you have to calculate the w's. So which is the w which gives the maximum of this equation, minimum of this equation. First of all, minimum of summation of I equal to 1 to n minus of xi transpose. So instead of doing the minus, what we do, we can write simply also the same thing. So instead of just minimizing it, what we do is we can say max of this equation 1 by n summation of I equal to 1 to n xi transpose w square. So instead of saying minimum of w, you can say max of w. So you want the w which give maximum of this value, because this minimum sign, minus sign I removed, that's why it become max. If I put minus of this w, this equation, minus of this, then it should be minimum. So finally, what, now we come to the point, you need to find out. So don't think about now the minus. Okay, we were earlier doing something like minimum of this summation of these proxy values. Okay, I just here. So what was our goal? Our goal was I want to do the summation of these proxies. I want to do the summation of all the proxies, and the summation which gives you the minimum, I want to do here also. I want to do summation of the proxies for this line also. Okay, and the summation which gives, so you will think that you earlier decided I will go with the value line L1 or L2 which give me the minimum value or less summation of the error. So instead of calculating summation, you can also do one thing here. Try to get w which gives you max of this value. Try to get a w which gives you max of 1 by n summation of I equal to 1 to n xi transpose w square. So instead of like we thought that we do the summation of the proxies xi comma xi transpose w into w some square. Instead of this summation of everything, see, this is a little bit bigger equation. But if you just simply say that, okay, instead of just calculating the proxies and calculating this proxy and deciding which L1 and L2 should I take, I will just see that only this w. I want to take the w which increases the value of this equation. I want to take this w which increases the value of this equation xi transpose w square. So I divided by n. So you need to figure out, instead of calculating the summation of all the proxies and trying to see which is the minimum proxies summation. Instead of that, you can simply just go with this concept. Then instead of minimizing that, you can just maximize the W, get the W which maximize this equation. So get the W which can maximize this equation. So that W will give you the direction of the that W, that W what you got, like this W, if you get W1 comma W2, this gives you the best direction of the line where which is passing through origin. Okay, the origin is very much important. Our line should every time pass through the origin. So pass through the origin and that point, that line is the best line to represent the data. So that time kind of a W if we get, then we will immediately understood that L1 is better or L2 is better. So you no need to calculate the summation of all the proxies or summation of the error. Summation of error equal to maximum, like I am not saying this is like the what we are trying to solve, the summation of the error which was the minimum summation you want to do. But here you are just simply changing your point, that you are trying to figure out, instead of finding the summation, you are trying to figure out the value of W which maximize this equation what is here. Okay, so this will give you the line which is very much important, which is like giving you the trend of the situation, what is the best trend going on in your data. So this is something here. Okay, so if I, because this is something what you want to do, and this is still has the square here, the square term. So if you don't want to use the square, we will just simply also go to the next line, like we can just simply say that solve it also, because this is square. So square is what, see, W transpose X is same as X transpose W. You can solve, maybe you can find the solution, but W transpose X is same as X transpose W. So Xi transpose W is also we can write as W transpose X into X transpose W, because it's the same, both are same. So instead of writing Xi transpose W into Xi transpose W, you are just simply writing this way. Okay, so here what we do, because see, you will understand this is throughout this subject, this is one type of a kernel. Okay, but we'll come to that point later. But this is now what I'm just rearranging this here. So what we do is W transpose X, we are just now combining this matrix. Okay, and now you get it down here. One second. Yeah, so what you understood here, one second guys, let me this is a little challenging for me on my weekends. So here the point is, here we now understood that, because W is something like, you know, that this is something you will get that, because these are not changing when. So we can take this W out, W transpose. Just remember, like, you don't need to stress your mind, but I'm just, because next point is what I want to mention is something, this is Xi, because it's summation Xi into Xi transpose W. So this is what, this is the D cross D matrix. See, this point is a little bit important for the week 2. Okay, but this is what the D cross D matrix. Okay, so now you have already the in the question, or maybe when you solve some kind of actual real time problem, you have a big data set. On the data set having this kind of matrix values and all. So this is what exactly here you will get, that Xi transpose X. So now what we said that earlier, you have to find out the this equation, you have to figure out the maximum, but that maximum also has the square value. This is the square value, the maximum has the square value. And you don't want to do square, because doing square is little bit more like complexity, like time consuming. If you do on hardware, it will also use some kind of another algorithm to do this kind of solution. But here, instead of doing this square, what you are doing, you are just trying to reduce this. I'm just trying to, okay, this is max, how I can minimize this. Okay, so what happened here, you are actually trying to reduce this and bring it to this equation. This is what the equation you are bringing. So equivalently, what I can say here, earlier what we did, that this is what W transpose and W, and this is what now this point, because I had just rearranged the point. Okay, xi transpose, and this is what I did, xi, I forgot to put xi, and this xi. Okay, and this xi. So this inside this component is the covariance matrix. So here you have to calculate eigenvalue and eigenvector on this matrix. This is what covariance. So I will write down the name as C to that. C means that covariance. Okay, covariance, and the remaining this W here, this W. So what C is here, so what C is here, C is nothing but covariance matrix is equal to, that covariance matrix is 1 by n summation of 1 to, so you have to calculate this one in your exam also. Okay, so this is xi into xi transpose. So this is what the covariance matrix you have to calculate. You have to calculate the covariance matrix, its eigenvalue, eigenvectors, and then you will like simply get the actual data. But actual vectors, eigenvectors and directions and all, you can plot that point. But how we come to that point, you are now, like, this is something the important of this equation is that to bring you to the covariance matrix. So we were started with the calculation of the proxies, that trying to get the maximum summation of these, trying to get the summation of the all the proxies, and see that which has the minimum summation, that will choose that baseline. So you said that okay, that's not good option, can we do in another way? So what we did, now we are now trying to get the max of the W. Okay, where W transpose covariance of this matrix, covariance of into W. Okay, you are trying to maximizing this W, and remember W square is 1, that you are every time going with the unit circle. Okay, so you are just actually, yeah, okay, so what you are doing is you are trying to get the maximization of, you are trying to get the W which maximize this equation, W transpose CW. And what is C? C is the covariance matrix, which can be written something like here 1 upon n, I upon n to n, xi transpose in. This is what the C, this is what the C value, covariance. So this is what your covariance matrix. So you have to figure out the covariance matrix, you have to figure out the covariance matrix, calculate the covariance matrix, then its eigenvalue and eigenvector. So how you calculate the covariance matrix, you have to figure out the W which gives you the maximum of this value, W transpose C into W. So this is what the equation is there. You have to get the maximum of this value, you have to get the W value, you have to get, W means what, you have to get this direction or this direction, you have to get the maximum of this, like instead of, like we earlier said that minimum of this summation of this, so instead of saying that minimum, we converted that min to max now. So we have to kind of find out the W which gives you maximum of this value, maximum of W transpose CW. C is what? Covariance matrix. You have to figure out the W which gives the maximum of CW here, whether you should go with this or whether you should go with this. So this way you will understand which line is the best for my purpose, which line is the best one. Or this equation, this gives you the eigenvector, because as I mentioned, this is covariance matrix. You will calculate the covariance, because you know that the formula is like a minus lambda I equal to 0, and then you will calculate the lambda. C means what? The covariance is a means here, this is the covariance. Okay, a means what? You will calculate this, like you have maybe gone through the MLF, you understood like here. So how you calculate eigenvalue? A, you put this covariance matrix here minus lambda I, and then you find out the eigenvalue, and you will say that okay, these eigenvalues are here, and the corresponding eigenvector is the W value eigenvector. So here you did, if you see here, now if you see here, if you get the C value, you will also get the W value. If you see this, if you get this covariance matrix, if you find out the covariance matrix, you will also find out the W value, which is like the solution what you want. So here with this solution, covariance matrix is nothing but 1 by n summation of I equal to 1 to n xi into xi transpose. If you get this covariance matrix, because you have the data in your question, you try to find out the lambda and W is what? Eigenvector. That is giving you the actual direction. Now that is giving you this direction or this direction, which is the best direction. So that is what the eigenvector, and that what PCA will also do. That the PCA will give you the eigenvector calculation, what the eigenvector is there, and that is what the giving you the trend, which direction the maximum variance or maximum changes are happening, or maximum trend is going on, which direction. So that give you this W, which is the eigenvector. So eigenvector, how you calculate? By using the covariance matrix. So covariance matrix here is xi into xi transpose, and how you got the covariance matrix is, you need to find out what is the line which give you the best max value of W transpose C into W, which gives the point W which gives the max of this value, this equation. I know this is something more mathematical, but the point is, the actual aim was behind it to figure out which is the best L1 or L2, which L1 or L2 means which is the best W, this W or this W. So you are trying to figure out which W is the best, and how you calculate W is nothing but your eigenvector. And how you get eigenvector? By calculating the covariance matrix, which is xi into xi transpose, and then you do the summation of that, and then averaging it, you will get C, the covariance matrix. Then calculate the lambda, this eigenvalue, and then after this lambda you will get the corresponding eigenvector. The maximum lambda gives the eigenvector. So that is what the actual W which you are interested. So that W will give me the best line here. So this is the best line. Instead of this, I will choose this best line. And now here I am considering every point will be dropped on this line, and then I can use representative and proxy value to get the compression. So you are very near to the PCA algorithm, but this is what the basic of the PCA, what exactly, like not PCA started, but this is how the PCA will now come. So this is all I am explaining in 2D. I am not saying in 3D, but this is what the 2D, because I just mention every time the representation in this x and y. So this is 2D. But if you go in 3D, then this will be little more calculation of view, but that is something not difficult. If you understood that, what do you want? Like I want the minimum error, you can get the minimum. Like how you find out the line? You can find out the line by calculating the error or calculating the W. So you have two ways: get the error, sum all the error, do the minimum of that summation of the error, or get the W which maximize the equation. Which one is the best? You can choose which one is the best, and you can just derive the line L1 or L2 or whatever may be the line. So choose the summation of the error, or you can choose the W which gives the maximum of W transpose, which gives maximum of W transpose C into W. I want a W which gives the maximum of this value, W transpose C into W. Okay. So I know this is big math things. If I just simply give you that, okay, this is the equation, but you won't understand the use of the algorithm. Maybe you will understand only the formula, you will maybe get good marks. But if you say I learn ML algorithms, so you should know what is this actually derived from. If you don't remember 100%, it's okay, but later on in future, if once you read that video or once you understood that, try to go through the video, you will remember the things like why sir is calculating W, why he is calculating mean, and then why he went to the max. Some instead of like a mean of a minimum of all summation of the proxies, where there is like a square term will come. So instead of that, you can simply go with the maximizing the W, maximizing the some value which is W transpose CW, maximizing that value, that W I want to get the actual direction of this here L1. So you can get the L1 through summation of error, or you can get the L1 through W value calculation. So this is something video 1.4 or 1.5 or 1.4, I think so. Yeah, 1.4 video. Just remember the equation. C is nothing but, you in mostly the exam the questions ask, and then you need to remember this equation. C is nothing but 1 by n summation of I equal to 1 to xi into xi transpose. So just do xi into xi transpose and then do the summation for all the points, then you will get the C value. And C is what? C is D cross D. Okay, this is covariance matrix. Okay, it is D cross D. It is not a scalar value, it is covariance matrix. Covariance. So W transpose covariance into W. So this is D cross D matrix. Okay, I know this is little bit mathematical things, but I thought it's, if I just simply skip this, then you will not understand. And what our main aim is to understand the algorithm, not the formulas, not simply understood the meaning of the formula. Get the formula, get the out of mark. So if you have any questions right now, you can ask me. So in week 1 we have total week 1.1, 1.2, 1.3 like this till 1.7. Okay, so 1.7 is total 1.6, and 1.7 is the videos on actual PCA, and 1.5, 1.6 is like bringing you to the PCA. So any question till now? Just don't remember the formula. Just tell me what you understood now. What you understood from the discussion. Like, not give me like if somebody asks you, did you like the recipe? So you may like the recipe. It's okay. But I'm not asking how you prepared, like 50 gram of this, 50 gram of this. I'm not interested into that. I'm just asking you what you understood from this. I have given you um, X data. I have given you some CSC, some file data in the Excel sheet, and I ask you, because it's an unsupervised learning. Okay, in unsupervised learning, you don't have any label. Nobody is giving you the label. Nobody is telling you this is the label for this is the expected output. Nobody is giving you. Our own unsupervised learning algorithms has to understand from the given data, like whether the data has this relationship or whether the data has this relationship. If it understands the relationship, it will just create the clusters or it will create the group, or this will help you to figure out whether he is because in face detection algorithm in future, if you are plotting, if you are writing the algorithm for your organization, or you are writing your own algorithm for your own company, and you said that I want to do face detection, there you don't have a data of a person's complete face. Like for example, you have data but you don't know whether the same person is there or whether he is a different person. Okay, whether the same person in some lighting condition, maybe there is little dark, or some light is from another side of the face, so you will just get one face more brighter, another side of the face is little dull. But you have to figure out that you don't have a data, and here you don't need to do clustering, because clustering is not the application of the face detection here as of now. With this, your face detection, I am saying, you are using in your office, like for attendance calculation or something. Okay, or some other places like in the police station or anywhere, or in the courtroom, they are putting the cameras where they are checking the people face and or whether like all are there or they are not there or something, some different application. So you are not doing clustering, like you are not saying he is a human or he is not human. Because in offices all are human, they are coming to office for work. So that is not the application of clustering, that is now application of your face recognition. So how the PCA start working into that? So this way we have to start understanding the algorithm. So maybe I have the code. Maybe this is I hope I can show you that. Okay, maybe I will just check. Maybe I'll check. I'll just open my VS Code, but because yesterday I tried to write this, write means I use GPT, also GPT only, but I know the steps, like how we calculate PCA, the same way I did it for the face recognition algorithm. So one second, but before that, you guys have any questions, you can ask me. Murli sir, anything? Okay. Yeah, because maybe what our sir's videos are there, na? Arun sir's videos are very very helpful, because so if you go through that you will understand, but at some point you will lose the track. You will see that why he's doing. So you will only finally understand that okay, the formula is this one. That's all. I will get good marks. But then yes, yes, yes. So you will understand. Maybe you don't need to spend more time afterwards. Also, you simply one time watch. You will understand what's. Yes, yes. Firoz, any question, man? Firoz is on mute. Priti, ma'am, do you have any question? Okay, and Tejas, Tejas, correct? Tejas, Kat, Katta, Tejas. Oh, sorry, I cannot see the full name here. I'm sorry for that. Okay, okay. Because here you don't need to like understood like complete the steps, but at least you should be get familiar. Like maybe if somebody is explaining or in videos or TAs are explaining, then you will understand why he is doing that. So if you understood this theme of that algorithm, then definitely that will help you to understand the big picture, why we are doing. And maybe at the end, the session is not at end, but but because these things will be more mathematics, so I don't want like you guys to go into more math things and get bored. Yes, correct. Yes, yes, because what I did, correct, correct. I actually tried to do yesterday, na, that the calculation. I'm just trying to see because what I have explained you. Yes, I will just use 1 second. Huh? I will just open. Yes, yeah, I will just open my collab file where I have just done this piece small data on the PCA. But because it's not at PCA, so I because PCA is having another steps. There are few more steps there. So I thought that after this small, there is one more discussion is pending. Once that is finished, now then it's good to show you that what exactly because I will go with the small data only, but with the same step of PCA. But this is something not exactly the we are on the way to the PCA, but not the complete PCA. This is not the PCA algorithm, not fully. So we have to add something in that to make it PCA. But you understood right now the eigenvalue, eigenvector, which is also the part of PCA. You understood the covariance matrix. That's perfectly fine. But there is one step is remaining, which is you need to find out. For example, I will just yep, I will just give you here. So I will come to the point because as I mentioned, this is your data. Okay, this is your data. Okay, and your data, like this line, you will say that okay, this is a best line, you can say, but this line is not passing through the origin, and then this a problem will come, like you will say, oh, this line is not passing through the origin, there is some extra you are adding here. Okay, and you need to actually go through the vector or w which has to pass through the origin and this direction, that is actually w, this w. So then you have to bring that all the points the early near to that here, so the you have, yes, 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 we have to center the data. So what you have to do, what you are doing, you are moving this point, you are moving this point to here, this point to here, this point to here, this point to here. You are doing some kind of a subtraction, you are just bringing it to here. All the points are now moving towards, like there are some value you are moving, you don't know what value, but that value is nothing but the mean value, mean, that is nothing but your mean. So x minus your mean, that data minus your mean. So you have complete x and y, like you got one graph, one table, and they will say that this is point 0.1, point 0.2, like 2 comma 3, 4 comma 6. Then what you do the summation of x, summation of y total here, and you divide like total. For example, these are 2 points. Okay, it's like a 6, 4, 4, 2 and 4 is 6. So 6 and this, if you do is summation is 6, is summation is 9, and if you do the average of this, like I am just simply taking two values, it's not a good example, but 6 by 3, it's just like average is 3 and this average is 4.5, like average of summation of x, summation of y. I do, this is the mean value of the data, 2 points. Okay, this is the mean value. So I am just subtracting. Now what happened now here in next, you when you are solving the questions now, so you have to do x minus mean and y minus mean. Okay, so 2 minus 3 and 4 minus 3, this is the x value. Okay, this is the x value, this is x, and for y minus mean is this y is 3 and this is 4.5 minus 4.5. Okay, 6, this is 6 minus 4.5. So you will get x minus mean, y minus mean, means you are just bringing it to the center. Now instead of drawing this line, now I am happy that my line passed through origin and also in the direction, so that is like a proper w value. Now it's helped me to draw the line, like some all, if the points are shifted here, then instead of this line I am just drawing this line. So that helps me to go with the steps in the PCA. So once you like do that, so we are not now at the PCA level, But I'm saying now once you do this mean calculation, so you get now the different data. These are like x dash and this is y dash. Like x dash comma y dash is your new point now because it's now shifted. So here you will calculate the covariance matrix. Covariance is what? 1 by n xi into xi transpose, and this you have to do summation of all the values. This if you just do transpose and all, you have to do the summation of these values and you will get a covariance matrix, and then you will just calculate. The covariance matrix is nothing but your covariance is, and then you have to get the c minus lambda I, what our earlier equation, c minus lambda I. You calculate c equal to c minus lambda I equation, determinant equal to 0, and c is nothing but your covariance matrix, and you will just put the equation and get the lambda value, eigenvalues, and corresponding, which is the maximum lambda, corresponding to that you will get eigenvectors, which is w. So that is how, like, this is not the actual, this is like some small example I gave you, but there won't be a 2 point. There will be, maybe for the exam point of view, they will give you 7-8 points and all, p1 p2 p3 p4. But if you have if you have a bigger data and you are working in some organization, you have to calculate some more data, because the example which I want to show you, this is on the face recognition, which is like Yale. YALE is one university, Yale. So they have the big data of 28 people, and each person is showing different kind of face in lighting and other conditions. Like there are maybe 568 ways one person is showing his photo, like he is having different face expression, different lighting condition and all. So like each 28 into this much, so you have this much of data. But I just give you this 2 points, but there are like a bigger in real time example are different, and they are like a huge data set. But I just mentioned you, this is the how you just need to do the PCA. But before that, there are some points are remaining which you should know, because now you understood W1, but you don't know about next principal component, because you know that there is always the W1 W2 we say that, but what is W2 you don't know. W2 is also very much important, because W1 is just simply the direction of variance, but why there is also one another component, or there is another eigenvector, we say that is like a W2, which is the next value we need to calculate. So that point we'll discuss now shortly. Okay, so this is Murli sir, this is a small example I just showed you, but maybe after this finishing things, I will give you this face recognition, and I will also show you the final output of the face recognition. And in that video, maybe we can take one dog video and we'll try to say it's a human or not. We'll try to see whether we can recreate the dog face to its original or not. Because see, one person is coming there standing and showing his face, and you will say you are detecting the person. But here what happened, like for example, Ashwin is going to office, and the office is showing Ashwin is present. But first of all, it has to recognize whether he is a person or not. Once he recognizes that, then there is another algorithm like supervised learning. There is like it's not simply PCA will do, but for recognition and all system, what they have, like they have trained the algorithm in such a way that Ashwin looks like this, so they have like labels later on. So I'm telling real time work. You are not simply go with the one only, like unsupervised learning and just that's all, that is my product. No, you have to do unsupervised learning with supervised learning, or sometime reinforcement learning also. In the autonomous car, not only you do reinforcement learning, but they also use supervised and unsupervised learning, all algorithms together in Tesla, because Tesla is not using radar or lidar sensors. They are just believing on the cameras. If you introduce more and more sensors, your cost will increase more, because the sensors will also take more energy and more like power consumption, electric, because these are electric vehicles. You have to control on the things which you are introducing in a car. If it is consuming more energy, you have to figure out some other solution. So instead of that, they use more cameras, create the images, and then that images will help you to detect the things. So for that they use reinforcement learning, and that reinforcement learning will come with package of supervised learning, unsupervised learning, maybe different PCA, and lots of algorithms they may use internally. So don't consider in real time that you are just simply going with unsupervised learning only. You have to go with the combination of supervised, unsupervised, and all mixture. Okay, so in offices, first of all, to detect the face, you can say is a human or not. So you can use this PCA, but to train whether he is a human is fine, but whether he is Ashwin or not, then you have to use supervised learning for that. There should be label for that. Ashwin's faces look like this in all conditions, lighting, non-lighting, dull, or like this. So you have to figure out which is the who is the person with the label. So that will be used in supervised things. But this is the combination in real time. Okay, but now we are just going with the unsupervised learning. So this is small example I have given you what is the unsupervised learning things here, how we can just derive the covariance calculation and all. So why we did mean, because we have to bring all the data towards the center. You have to make the centered data. So for centering, you are subtracting the mean from the from that data and to bring it to the centered area. So then it will help you to calculate the actual line L1. So this is not the correct line. So this line is the correct line L, because you are centered and this W is gone through that. So it has to pass through origin, and this is the direction. Okay, so now we understood. Okay, we did you understand now here? So because this is now the next point which we consider in something like I'm going with the some 3D projection of this data, not a 2D, because now we whatever you are seeing these graphs and all, these are all these graphs are all like 2D graphs, but because the real time data is not in 2D, there is no height and weight only, height versus weight. This is, for example, this is the graph, but there is another point called as age. So you will get now three: height, weight, and age. So you have to get more 3D representation of the graph. Or if there are more points like d equal to 4, height, weight, age, or maybe or maybe color. So there is another projection, 4D, 5D, 6D. So there will be huge so our mind is like we know till 3D because we can visualize this, but 4D will come means we can't do that much. We are not comfortable in visualization. So I'm just giving you the example of 3D as of now to explain you why we are going to the 3D. But we are just now going to with the, because we have gone through the 2D projections here, and now we are checking with the 3D. Okay, so you understood, like this is the graph what we have drawn, like this is x, y, and z. So I cannot like not able to draw the 3D concept here, but for example this is 3D points are here. There is something like x comma y comma z. So there is some x, y, z axis. Okay, so these are the points. So this is the point, this is the point, this is the point, for example. Okay, this is another point, this is a point, and they are not on the actual on the graph. It is actually on the axis. They are actually on in air. Okay, in air means there is something like plane which pass to the origin. Okay, so these are the points. For this is the point, this is the point, this is the point. Okay, these are the points. This is this video is video 1.5. Okay, so if you understand that 1.5 video is of this question. Okay, so these points are here, all they are on the all these points are, this is a 3D picture, all the points are in the 3D plane. They are on the plane, they are not different they are not outside the plane, they are on the plane, because here all the points. and if the points are on the plane, the line will also be on the plane here, the line, because you want some better line, and you want better line, but the line should be also on the plane. So don't try to stress your mind, but just consider the points are on the plane in 3D, and the line should also go through the plane. Okay, because you want the line, basically you want the line which will represent, and you will say that okay, this is the line. So what you do, you just calculate the proxy, you do this calculation, you just put the proxy like this. You will say that okay, the points are on the line. So for example, consider one paper in the air. Okay, like you are taking a paper in your hand and you put horizontally the paper, and the points are on the paper, and the line will also is on the paper, and this is the paper. Okay, this is the paper, your hand is somewhere here, you hold your hand something, your fingers are here. Okay, something, the paper, and the points are on the paper, or something, the mustard seeds are there on the paper, mustard seeds. Consider this example, mustard seeds. Okay, and the mustard seeds, and you are trying to see that whether the mustard seeds are there properly distributed or not, or which direction they are like spreaded. So you draw some line on the paper, or you put some stick on the paper, and you say okay, I feel these are the mustard seeds, and I feel this is what the seeds are placed like this way. Okay, so this is what I mentioned, this is a stick, and you are saying one mustard seed is here, one 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 is here. So what you did, you said this is the baseline, I can see it here because the points are spreaded this way. Okay, points are spread this way. So you just plot your, as usual we are saying, we are plotting our projection, we are drawing the projections here. Okay, so once you draw the projections, so what happened here, because these are the these are the proxies along the plane. Okay, proxy along the plane, along the plane, the mustard seeds are already here, and these are the projections, and they are like simply on the plane. This is the plane, paper is the plane, consider. They are not like, not vertically, they all are like lying on the paper, and the mustard the stick is also lying on the paper, this stick, and you are just simply drawing like this these projections. Okay, so here, so if you see that the lines here, these lines, this line, this line, these are the proxies. Okay, so if I just remove these completely, now I am just now I want to see what these lines are like. So for example, one second, I am not now showing you this. Okay, so I will just draw the, I will just remove the things, and what to okay, I actually I did in my another laptop these things to I thought to show. I have this everything yesterday while creating this demo. I have it. Let me log into my laptop, or because this is already there. But this is something, the point which is just for your understanding. It's not like very much like related with the um, um, exam point of view. But yeah, I have the Desmos. Okay, oh, okay, okay. Let me open it. So you guys are like you did you have earlier used that Desmos 3D plotting things? Anyone? Okay, because okay, yeah, yeah. Because yesterday I tried it. It helped me. Um, to, to, okay, then leave it. My another laptop also need to charge and all, but I will just try to open this here. Uh, uh, Desmos. Can you see the screen? You guys see the screen? Okay, I think I'm just mm, okay, okay. Okay, okay. Because I just plotted the graph, but we can maybe just for time being you visualize this because now we just need till now here. So if you go with GeoGebra, it's also good, but unfortunately I need to do some changes here. But consider this is something as of now. Just consider this is how the 3D looks like. Okay. Um, is okay. Okay, so what happened now, you found that this is one line, and what we did, we just plotted, we just did the proxy on this. Okay, so if you see the proxy, so in earlier cases what we consider, this is the error. In 2D what we consider, this is the simply the error in 2D case. Okay, and we want to reduce that. We were not bothering about more about the error, so we were thinking that okay, these are the errors. But in 3D case, these are not only error, that also has some kind of information, because this is one dimension, na? This is one kind of xyz. This is one kind of a dimension. You cannot simply say this is the error. This has some kind of information, so you should not lose that point also. So if I just simply plot this, so this looks like this. Here something, here something, here. So these are the proxies in 3D. Okay, but now these are something like E1, E2, E3, E4. These are having some value and these are having some informations. These are not simply the error, or you cannot discard that. It has some kind of information. And if I just simply, just make them together, because see, all are like perpendicular. Okay, so if I just say that all are like perpendicular here, and if I just, if I here, if I here plot this line from the center, this is not E1, this is E4. E4 I will plot like this, E4. Now E5, E5. I'm trying to just bring all them together here, in which is passing to the center. Okay, E5. Then E6, this E6 down, E6. Then E7 up, E7. Okay, then E4, like this way you will get one line which pass through the origin. So you can see earlier you were trying to figure out something this way, the trend, the W1, but there is something line which also pass through the origin and also has some kind of information, because this way you understand there is a trend, but what is happening here, there is some information. That point will come, because this is something also, it's kind of a rotation, but these all the points, that point will come to the next point, next thing, but these are like the points here, this point. So I'm just saying this point is here, I'm just drawing this way, because all are perpendicular, so you can just sum that point to here and make it like the line passing through the origin, the same point, same this way, same this way, same this way, same this way. So I'm just saying the same line. So all are like perpendicular to this line, like all can you repeat that, your voice? Yes, so something like this image. So instead of saying here, 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 I'm just saying that all are now here on this line, because all are like perpendicular, correct? All are like orthogonal to this line. So instead of saying like this, I'm saying all are, instead of all are drawing this way, I'm saying they can be drawn like this, like just for representation. Okay, so this saying that this is not simply the error, this might have some information. See, if you draw like this is becoming huge, like the maximum value which has the maximum, like maybe E7 is something like this, so here E7 is something like this. So this has some information, so I want to show you, if I draw like this, it shows some kind of information. It is not simply, you can't discard that value in 3D. You can't simply, because normally the, as I mentioned, this height, weight, age, color, and all these are like the parameters, they are going to the dimensions, correct? So if you are increasing the dimensions, means there are more information stored in your error also. So you cannot simply discard that information. These are not simply the error. So the error, what we earlier said, this error is what? X minus, you know that x minus x transpose w into w, x minus c into w. Na? That what we did here is x, and this is what? Cw. So that c is what? X transpose w. C is equal to x transpose w, and this w is as it is here. Okay, so that is what? X minus Cw. So this is what the error, you know that, correct? So here, so you know, like now this has some information, but you don't know what is that information. But now you got this is 1 point, this is 1 point. Now earlier we said that this is x1, x1 is 1 point, x1 is 1 point, x2 is another point, x3 is 1 point. These are the points. But now we understood, now in this case we understood this is 1 point now combinedly, because now this is error, this is 1 point, this is 1 point, this is 1 point. Now these are the 1 point. So these are not the error, these are also the points, these are also the points. So you consider now this is as a 1 point instead of now this as error as a 1 point, and we use this 1 point, we use this as a 1 point and calculate the next next direction. Like w1 you have calculated, but you have to calculate the next w2. W2 is nothing but the eigenvector only, but you should know whether it should be calculated or not, whether it's a good point to calculate, or whether we can simply like reject that point. So that's what the important thing. Okay, so you have to calculate this w1 and w2 here. So this is the same algorithm, it's the same algorithm. So w2, the same point what we did for w1, you are just trying to consider instead of x1, what you did w transpose, oh sorry, here. So what we did here earlier, what we did w transpose c w, we have to maximize, because you come to the point here that, 1 second, maybe I will just draw, I just yeah, okay. So what we did earlier, w c w transpose w, maximize this value to get w. You need a sum w which will maximize this value, correct? So that give you the direction of w. So same way you have to find out the direction of the w2, which gives you max of w transpose, but now here it's a c dash w, correct? Why c dash? Because you know now earlier point was x, like simply x, but now the point is x minus your error matrix, x minus x transpose w into w. This is your point. Earlier point was here x, but now you are interested in this error and you are putting all the errors here. These are the error. When this point is what? Error. This is now our single point, x minus x transpose into w. This is your point, this is just single point, and you are now what you did, x into x transpose. What is c? C is what? C is 1 upon summation of I equal to 1 to n xi into xi transpose. So that is for good w calculation, this w calculation. Okay, but now instead of this xi you are taking xi minus this value, xi minus xi transpose w into w minus, okay, sorry, this one into, and then you have to type xi minus xi transpose w into w transpose, because see this one, so you are saying this. So here you are just doing the same calculation, but you are checking the points as xi minus xi transpose w into w. So earlier your point was simply x, but now your point is now this error xi minus, because you found that this earlier what you said, earlier you said that xi is the good point because I cannot discard this x point. You don't want to discard this point, correct? You are just taking all the points, you are taking the proxy and all you are taking, but for next w eigenvector calculation you are considering this as a 1 point now. this next is this one has a point now. So these are having some value. So this point is what? These are the error values. These are the error, like x minus x transpose w into w, because this is what, this is x and this is cw. And if you want to find out this length, x minus x transpose w into cw, x minus this means this value. So you are considering this value, and now you understood that okay, there is another w, because this give me w for this side. And now if I just use this value, this equation with using this xi minus xi transpose w, I will get another direction as this. So this is another w. Okay, this is something the different w. So till now you get that, because I'm not solving the equation. There is like a huge big equation sir has solved in the 1.6 video, but this equation which like something what sir has done, I have just explained. Like you know that what we have done, like we just did this w transpose c calculation. C is what? Covariance matrix. Okay, covariance matrix. And with that covariance matrix you calculated the w, the value of w, which give the max of w transpose cw. But you are also interested in this dimension, because there is some value, because errors are not the point which you want to discard, they are also having some information, and you want that particular value also. So for that reason you are interested into calculation of this error matrix. So what it shows you, something like, for example, I will just now draw, okay, unit circle, because unit circle is very much important. W1 square plus W2, and this is what? W direction. Okay, and I'm just plotting the this proxies on W1. This is W1. Okay, and this is here. This point I'm just drawing here. Maybe I can use another color. So this point I will draw here. Okay, and there is another few more points. Just see that, like it's not that you should know understood, like you should like stress your mind what is this, what is it, not a problem. Just simply see what exactly this is doing. So these are the any points, these are the proxy points. You are just trying to get what is W2. Like now after solving, doing all the courses MLF and all, you understood like there is two principal components or two eigenvectors you are getting. But what is that two eigenvectors, that you want to know it here. Okay, so these are the points, and these are the proxies of the points what I have just drawn it here. Okay, and what happened now, you are just, this is the proxy along W1, and you are just now plotting the same thing here, like here, this may be here, this may be here. I'm just plotting on this W2. I'm plotting these points on the W2. Okay, here there is maybe another here. Okay, all the points are now here, these lines. So W1, you understood there is W1 and there is another W2. So and you know that what is this, like for example this is this point is example, this is x2. So what is this point? Is x2 minus c into x2 minus c into, this is W1 now, because this point is here, W1. So c into W1, I'm sorry, x, because I'm just replacing the c with x transpose W. So here, okay, so yep, what happened? Okay, now it's come. So I'm just representing this this x2 minus this value, x2 transpose W1 into W1, because these are the points of here. So c into W1, so that I am representing here this way. Okay, this point, like same way, similarly, then this is maybe x1 is here, x1 minus x1 transpose W1 into W1, this point. Okay, so similarly other points are also the same way, like x1 x2 and this is x3. Okay, this is x3 the same way, and c into w1 because they are on the this w1, this is the w1 line. Okay, same way. Okay, so similarly I am just plotting whatever the proxies are there, and here you understood that because here w1 is going this way and the w2, because these are the residual means we say x minus, this is called as residual or error or residual, you say error or residual. Okay, these residuals, these values, and if you see that they are going through the origin and also perpendicular to w1. So this w2 is also going through the origin and also perpendicular, and you know that we need every time perpendicular. You simply, because we have seen that in the graph, you are just taking this one is bigger error, this one is also bigger, this is also bigger, but the perpendicular is the smallest one. So this is the smallest error what we are checking here as per this. So these are not only perpendicular here, this is also perpendicular to here, correct? So the line which also take these perpendicular things here, 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 these all the lines, these all the points, this line w2, the w2 is the line which take all the points projections. Okay, these are the error, the residual projections. These are also perpendicular here, and also they are perpendicular to w2 w1. So so if I just plot properly, so w1 and w2 are orthogonal to each other, because you have already gone through the MLF, so you understood that okay, both are like perpendicular. So what is that? W2 transpose w1 will be 0. So they are orthogonal to each other, so that's why they, like, you know that the two lines are perpendicular, so their dot product is also equal to 0. So this is what you already know, but simply I just give the idea like what exactly these things. But what happened now is we have seen 2D case, we have seen 3D case, but somebody will say no, I have 4D, 5D, 6D and so many, because dimensions you don't know, like height, weight, age, color, and ethnicity, area of living, and there are so many points are there in the Excel sheet data, in your data. There are so many dimensions, these are the dimensions. So here with the 3D, you calculated one residual, like you got, like this is one proxy, and then you plotted on here, this is you plotted on this w1 and w2. But there is no limitation, maybe in the 3D, 4D, 5D, 6D scenarios, in where there are more dimensions, where there are like 1,000 of dimensions, then there will be huge w1, w2, w3, w4, w5, w6 also. Okay, there will be so many w1, w2. Okay, so you don't know, like you can't say. Now you are able to visualize this w1, you can see w2, you can see, you can visualize this in small, because here is very easy. And what is this w2? How you got? You just got the residual x1 minus this x1 transpose w1 into, this is the residual you got. Okay, this I will say residual. Okay, this is the residual. How you got residual? The same way this point you projected here. But in 3D, 4D, 5D, how you do? So what happened? W2 is taking residual from W1. So what will do W3? W3 is doing residual of W2. It has the, see, W1 is x2, but its residual is this, what we did, x2 minus x2 transpose W into W1. Okay, this is what the residual, this value. Okay, this value. Okay, this is for w2, but for w3 what? W3 has now this one as a point. Okay, w3's point is what? Residual is what? X minus x transpose w into w. This is what you calculate residual. Now this x and this x is replaced by this value, is replaced by this. For example, now x1 minus x transpose w1 into w1. Okay, this is what x minus once again x1 minus x transpose x1 transpose w into w. So this transpose into w. Okay, so this is w. Okay, so here this equation is increasing because this is the residual for w3. When you are calculating w3, you are taking w2 as a reference and you are calculating x minus x transpose w into w. So here this residual is increasing. This x is replaced by this, and next time what happen, this is 1x for w4. W4 is taking w3 as a reference, so this is one more time you are considering this big value as your reference, and you are calculating residual what, x minus x transpose w into w. This is your residual, and x is replaced by this much big quantity. Then you will say, how many times I should go, because you can't now visualize this because it's a multi-dimensional thing. You are able to visualize by using this 2D graph. You are just, I'm simply drawn here is this way, x1 w2 I got it here, w1 I got it here, w2 I got it here. Okay, for your exam point of view, w1 w2 is very good, you will get out of mark, you will be happy. But for calculating your face, your detection of your face, your actual algorithm in your offices, if you are doing this work, then you can't wait till w1 and w2. W is what? Principal component. You can't simply wait for just one principal component. You have to calculate 200, 300, 1000, 2000 principal component also to bring that actual image back. Okay, so that's why for exam point of view it's fine, you can just do w1 w2 calculation, you will get out of mark. But for actual work point of view, you cannot stop till w1 and w2, you have to do w3 calculation. But w3 what? W3 is taking you need to get this residual calculation, x minus x transpose w into w. This is the heart of this calculation for the next line. You can't visualize this line, but this is something, the next line w3, which is like also perpendicular to w1 w2 and w3. They are like perpendicular. Maybe this is maybe something, I can't draw it, maybe vertical 3D, you can see, imagine something like, all they are perpendicular to each other, all they are like orthonormal, they are calling as a orthonormal. Okay, these lines are like orthonormal. What is orthonormal? Like w1 w2 w3 w4 and so on till wd, like how many dimensions you are having. I have height, weight and age, w1 w2 w3. I have so many things, but that depends upon wd. Okay, but here for calculating every w, you have to do the residual calculation, and residual will go up increasing. For w3, as I showed you here, this is x for the w4 because this is the reference. So how many times you can go? So this is the main challenging thing. How many equations, how many iterations I should go? How many times should I go to find out the best line? Because see, w1 is what? Best line to represent this data. Correct? This is the w1. Okay. What is the w2? So there is height, weight, age, color and all. So there should be some value which should also represent some data here. Correct? This should be some data. If there is a human face, maybe this way I can represent eyes properly, but he has his hand like this. Okay, he has his hand, and I need to draw something like this. I need to get also the information from this line. Okay, so for that reason I need another w2. This way w1 I help me to get the information this line, but this way I will get information about w2 about hand. So you need more and more information to get all the info, or you need the more and more weights or more and more best line, which will give the information about your object which is present in your screen. Okay, so you need more and more best w values, which gives you the best line for the residual. Because see, here the point is like here these are the points. So this line represent the best line to fit for these data points. But what about W2? W2 are the residuals, correct? These are the residuals. This value is projected here, this value. So these are the residuals. So I want a baseline to represent this residual. For W3, this is also a residual, residual, correct? So I want some line W3, W4 also to fit the baseline for the residual. W5 also residual. So this will go on increasing. But where to stop? Where to stop this line? So for that reason, what happened at one point? At one point, the residual will go on 0, because see, once you are calculating the residual, once you are saying these are the error. So at one point, once you go W1, W2, W3, at one point they will become 0, na? The residual will not be stay as it is. Then if it is staying as it is, then W1 is sufficient. W2 is also not needed because they are same residual. W2 is like you can't do, no need to go. But residuals is what? Like you are having sugar cane, you are putting into the machine to get the juice, sugar cane juice. So first time you get some value, you get some residual from that. Like this is not the original x1, it's like x1 minus remove the juice. So there is another, and that guy, what he do, the shop owner, he will take the same residual, put it one more time into the machine. The machine will once again will take out the juice from that residual and get another x2 residual, and once again he put till what? Till complete things will go to 0. And once he feel that, oh, now it's like almost 0, like there won't be 0 every time, or there won't be 0, but it's like near to the 0, so he will throw that thing. So something like this. So if you do the residual calculation, it will become 0 at one point, because it's a math. So I'm not, this is something like sugarcane example is one example which he tried to make it like near to the 0. The sugarcane won't have any kind of a 0 juice inside this. That is a level. So same way, the residual will go in this way. You are calculating W, W2, W3, W4, and you are going in this way. At one point you will feel that all residuals are now 0. All residuals are now 0. So means what? So you are getting like x1 minus x1 transpose W into W minus, okay, x1 transpose W2, because now this is something another next point. I'm not saying now for the first round, it's now second round, okay. X1 x1 minus x1 transpose W1, so W1 into W1 transpose W2. So don't think this is just something like what I mentioned, like x minus x transpose W into W. So at every W value you have to calculate this formula. So x will get replaced by your earlier residual, okay. So what happened finally? At one level you will come to one point, because I'm not giving you the complete equation, bigger equation. I'm just showing you what happened after some D round, okay. Like, because this, as I mentioned you, that there are D dimensions, so D rounds will be there, and in that D down round I'm giving you the what will happen for the just one quantity x1. So x1 transpose W1 into W1 plus x1 sorry, it's xi transpose W2 into W2 plus, and so on, plus xi transpose WD into WD, because at the last moment I will get 0, because residual will become 0 na, at last moment. So if I just do like this, at the last moment, this is a starting point, this is the residual and all. So if I do at the dth round, I will get the equal to 0, because residual becomes 0, nothing is remaining. So what is that? That is nothing but, so if you can just simply write x1, because this is equal to 0, okay, that is nothing but, how you can say this xi, this is xi, sorry, not x1, this is xi, this is xi, this is xi, okay, that is nothing but xi can be represented as xi transpose W with W1 plus xi transpose W2 into W2 plus and so on xi transpose WD into WD. So instead of just simply earlier how we represent xi we represented like this x1 plus x2 plus x3 plus x4 like this. All the points we represent like these are the points. These are the points xy, x2, x3, x4 like this you represent like this. But now what we did, we represent xi with these bases w1, w2, wd. Correct? So don't try to go into this more how this math come, but just understand this formula. For W2 calculation, what we did, we can use the x minus x transpose W. These are the residual. This is the error. What we understood, like this is the point, and this is the error. Then we are just projecting the error here. Just projecting this error. For W, this is W2, this is W1. For W3, maybe I am not able to draw it properly. 4D we can't do that much proper drawing. But W3 will be orthonormal to W2, perpendicular to this W1 and W2, and that also take as this as a residual as one of like x parameter for this, and they calculate like this. And same way if you go to WD round, W2, W3, W4, W5, W6 like this WD round, so WD will take WD minus 1 point and then calculate the residual from that. And once you say that at last moment at dth round you will get error equal to 0 because there won't be any residual remaining, everything gone, the sugar cane is completely dried now, nothing is there inside this, so no error, so we mention as equal to 0 at dth round. So that is what we did. X, then by using like normal a minus b equal to 0, then it's nothing but a equal to b. So this formula we use here. So this is what we mention now. Xi is represented as xi transpose w1 into w1, xi transpose w2 into w2. So here you can see earlier simply representing x1, x2, x3, x4 and x5. Now we are changing that to this formula. Xi represented as xi w1, w1, xi transpose w2, w2. So we are changing the bases. So earlier base was simple x1, x2, x3, but now we are changing the bases and we are now using w1 and this value. So this w1 is what? W1, W2, W3 and so on is actually the representative, okay, and your xi transpose and your these values xi transpose w1 and wd, xi transpose w1 or xi transpose w2 or xi transpose w3, all these are your coefficients. So instead of representing the xn data like you are earlier taking n data, like if x1 is like Murli has 4 feature: height, weight, color and ethnicity or something, 4 feature. So these are the d, okay, d means the feature, d is equal to 4 in that case, okay. And how many data? D into n, this much data you need to store. But now what happened in this case, what you are doing, instead of storing this data, because this is different kind of base, this is like different basic, you are not having in the same domain, you move to the next domain, different domain, and you are now storing xi in terms of these values, okay. So in this one you are just storing the w1, w2, w3, these are the representative. So w1 and w2, like for example if I just go with one example, if it is a 100 dimension, consider this is the d is like a 100 dimension data. So d is equal to 100, if you say r equal to 100 dimension data, okay, in the 100 dimension data, and say that you are getting the residual, because maybe sometime if I just go with the sugarcane example, sometimes the sugarcane is very big enough and you have to use 3 to 4 rounds or 10, 6, 7 rounds to get the residual equal to 0, means to take out complete juice from that. Maybe it took 10 rounds. But if there is like a smaller sugarcane, then it will take maybe 3 to 4 rounds or 3 rounds to reduce to get the residual equal to 0. You don't need to go to complete. If you are having 100 of data, you don't need to go to 100. You just need to finish in W1, W2 and W3. Once you do W1, W2, W3, once you calculate this W1, this W2 and another level of W3, you will see that, oh, residual is 0. No need to go, because next data is will be, everything will be 0 only. No need to calculate W4, W5, W6, because they are like 0, because there is no residue, there is nothing remaining, residuals are 0. So you can stop there at this point. So what happened now, you just need to get this representative, only 3 representative in that 100 dimension. You just need 3 representative, and coefficient also x1 w1, sorry, xi transpose w1, xi transpose w2, xi transpose w3. So these are your only this much coefficient. So earlier what happened, you have to store d into n, like 100 into 100 dimensions. N is your maybe consider n as of now. 100 into n you need to store. N means number of people, like Ashwin, Murli and Tejaswini and so many people. Okay, so there are like 100 people, there are like n number of people with 100 in dimensions they are having. Okay, but here what you need to do, w1, w2, w3, and what w1 is equal to, if you see, actually the w1 is having some kind of a feature, like something x1 0.5 into x1, like height 0.5 height, 0.2 into weight, 0.1 into age. So it has all the features, x1, x2, it has all the not x1, but these are the dimensions, like these are the actual your age, height, weight, means how many dimensions you are having, d, and how many you are now taking, only 3 into d, so d is 100, so you are taking 100. So this w1, w2, w2 is like a 3 into 100. Okay, because w1 has, as I mentioned, your dimensions like this format, 1 into d1 plus 0.2 into d2, this way. d1, d2, d3 are your age, height, weight and this point. Okay, 3 into 100 you need there. Okay, and what is the remaining, you just need these 3 here, 1, 2 and this. So you need only 3 coefficient. Okay, so here, so these 3, but xi, these are the xi. Okay, how many xi are there, n xis are there, because you don't know how many points are there. So if you see here, so for example, if you take now d equal to d equal to 100, d equal to maybe take 500. Okay, 500 points are there, and each point is of sorry, d not here, n is equal to, if you consider n is equal to, okay, so this is important. Okay guys, this is important. N is equal to 500. 500 people are there, and each person has 100 features, height, weight, color and all you may say 100 features. Okay, so if I just do the, if you do the multiplication, how many points you need, if there is no comparison things, how many point we need, so you need this much points, like you need that much of space, or you need this much of information to store. So it's 50,000 for example. Okay, so you need 50,000, but in this case what happened, in this case what we did now here, okay, so d is your dimension. So what we did, we took only 3d, the 3d means here, okay, w1, w2, wt, 3 only, we just need 3, and xi w1, xi w2, xi w3. So this is what, this is another 3, and I is like, there are like n points, so 3 into n, which is nothing but, for in this case what happened, 3 into 100 points. Okay, this d means what, d means 100 plus 3 into 500, how much is 3, so 300 plus, so you are just, you are, you you can see it, or you guys can see it, hello, hello, Okay, because I don't know. My laptop screen, my laptop screen is showing that it is at this corner. So I was like, you guys were not able to see it. So now we understood, like now. So if you don't do the compression, it is taking 50,000, and if you do the compression, it is in 1800 only. In 1800 only, your work is done. You just need to convert into another domain, W1, W2, W3, and in 1800 points only you are able to represent the complete data, because here you don't need to store all the d datas or d dimensions. You don't need to store d dimensions, you because the W1, W2, W3 in three w vectors only, in these W1, W2, and maybe another W3, you will get the residual equal to 0. So you don't need to store complete information, complete points. Just simply you with that, like you have to store in these dimensions in this way, W1, W2, W3, and their corresponding coefficient. In that 1800 points only you can able to represent this data. So here you will definitely get the bigger and bigger compression. So what is this point? This point is nothing but, so this is what in maybe in any interviews they will ask the questions, or anywhere they will ask what is this point, because you now stop at 3. I mentioned 3 points, 3 after 3 iterations, or calculating the W1, W2, and W3. Afterwards the residual is 0. So you are saying only 3 equations. So what 3? 3 is some value. So that 3 value is nothing but what? So this is d into k. So we call this one as the k value. Okay, d into k plus k into n. So these are the values. So you have to find out the k now. But this d and this, if you don't have anything, if you don't have earlier anything, so what you have earlier, you have d into n. But now you compress the data using this W1, W2, and maybe another dimension W3, and maybe W4. Only using these W1, W2, W3, and W4, you are compressing the data. Instead of storing d into n like 50,000 in this case, instead of storing the 50,000 data, you are just storing 1800 data, and you are able to represent your complete data set. And this k value, you have to figure out what is this actually k, means like where should I stop the value, like should I stop now or should I wait for some more time. So how I can say that k is 3 or k is 2, because while doing the work you don't know, you have lots of data, you put everything in a for loop, and you are just going, and you have to find out where should I stop now. Should I stop here or should I just simply go? So that point is very much important in the point of view of the interviews or examination point of view. Okay, so 1 second. So here the k value is very much important. So you have to find how the value of k is you got, how you can get the k value. Okay, so till now we'll just connect the dots, how we come to that point. You understood we got W1, correct? How you got W1? You said like we'll just now come to this point. We'll not now go point next, but I will simply revise this. You say that, sir, we understood, sir, this is the point. Okay, and this point we have to put project here. We understood it. Very nice. Okay, very happy, sir. I am very much happy. L1 we got it, but sir, L1 or L2? Okay, how L1 and L2? I said okay, calculate all the proxies here, do the sum of all the proxies for this, and also for the same point for this, and you say that which is the minimum sum of proxies, that is the baseline. So then you said okay, I will do that. But next point I said that you, instead of doing that, you can simply calculate w value, which w has maximum of w transpose c into w. C is what? Covariance matrix. So the w which gives the maximum of this, that is the best one, that is the best line L1. You said okay, I understood. But you understood just w. But what about, sir, what about the other w's? Because we generally not having just simple single eigenvector, we have more eigenvectors, more data, because Our data is not a simple xy axis or linear data. Our data is like a bigger data. Our data is face data, our data is human photo data. So we not simply only want to see the face information, so we also need the complete information, of this. um, one second. Guys, just give me 1 minute. I will mute myself. I'll just take my daughter for 2 minutes. Okay, I'll just. मा काय झालं, मोल मोल मो खेळायला जा, बाहेर जा. ओलो ओलो ना ना मम्मा थोडं जा ना, घेऊन जा बॅग. Okay, super. This is the thing. Okay, so what happened now, you understood like till now that uh, we are now here. Oh sorry, where is it? Yeah, here. Okay, so you got w1, which is the base w1 w2, so that is fine, w1 is okay. But what happened about because we have not only two dimension data, we have 3D, 4D, 5D, 6D, lots of dimensions we are having. Because nowadays if you see our excel sheet data or any data which you get it from your organization, if you are like a data analyst and data analyst or any other role, okay, so that time you will get lots of data, lots of dimensions in that data, like lots of columns, and you have to figure out what is that column about, what is the relationship between each one column with other column, what is the trend from the data, what area, what side the data is going. So you have to figure out which is the best direction for that. And for that reason you not only get w1, you have to calculate w1, w2, w3, w4. But till what, should I go with w1, w2, w3, w4? How many points should I go? The point is like till you get a maximum information. Okay, maximum information. Maybe once I show you the PCA output now, again the face recognition, you will understand how many w's you have to calculate for that. So generally you won't stop at w4, w5 in real time. You have to do more and more, like 200 w, 300 w, like this. Okay, in real time you have to do that many w's. Okay, but at one point you will say that okay, I will stop. There will be some point where I have to stop, like the value of k, which we said that there is k value here, this k value I just mentioned. So this k value we have to stop at some point. But the what is that k, so how we can stop that value? So the for that value I will just now this is very important point of view. Okay, and in the big picture you will understand everything, but in the interviews they will ask what regularization parameter you put, what is this value, what you put, and then you will not understand like okay, what is this, because you only know covariance matrix, calculate eigenvalue, eigenvector, stop there. But in real time, once you are doing these big projects, then you have to wait, you have to stop, you have some hard stop at one point, so you know that point, which is that point. So that point is now we are understanding. So it is from week 1.6. okay, 1.6 the video, and that video has at the end they have mentioned, but maybe in the flow you will forget that, because I also forgot that time earlier, like what is the k. But after reading 2 3 4 times, then I understood like okay, there is value of k, you have to understood also. Okay, so what is k now we are doing. But before that, my question, like you guys, like did you understand, or at least you got some idea what is this? Anyway, like if you get it, this it's okay. Like I'm not expecting, I'm not asking other questions on top of that, but if you simply got the idea, I got w1 is fine, you got line, very good line, I got that. But if you can't stop at w1 only. If you just stop at w1, then it's very dangerous, because I thought that I will show you one image also. If I stop at only one principal component na, for example, if I give one face of the person and a face of the dog, if I give, and if I project on the principal component 1, what happen, you know, the face looks like a human, dog looks like a human. Okay, this is the problem, because there is a lots of data, you have more and more amount of data of human, and immediately you put one dog photo. Okay, the problem with this is like an outlier, you can say, and you have to say that whether he is a human, who is he is some person in your college, but he is not the person, he is he is an animal photo, he is a dog photo, he is not the human. But still your algorithm has to identify, because you have billions of data, your thousands of data, you have to understand whether he is the one person from the office or not. By mistake if somebody did that thing, because you know that in Aadhaar card, people have, like you guys have our own Aadhaar card, correct, but somebody just misuse things they did, and they put one Aadhaar card of Donald Trump, and they mentioned that he is Indian citizen with Aadhaar number and all. So you have to figure out, this is something like a outlier, they are like different people, and you should not simply generate the Aadhaar number for that person who is like fake. And so these kind of things, I'm just giving one example. So if there is a animal, it has to detect it's an animal, it's not a human. And if you project that with single principal component, what it show that, it show that you are just saying that if you project it on the maximum data, because maximum data is a human data, if you project the dog face with the one principal component, he looks like a human. Like you say, okay, he is a dog, but why he this face, this is the face of a human face. But for getting the dog's face, you have to do more and more principal component calculation, get more and more variance, and then you will find out, oh, this is the dog. You have to maybe do the 3000 principal components, then only you will understand he is not the human, he is actually the dog, because that time the actual image will represent as the dog, not the human. So that's the reason you have more and more principal component to get the actual information from the data. You can't stop till W1. Maybe for exam point of view you can stop till W1, it's very good, you will get out of mark. But for this point of view, where you have to work on the big projects, then you have to calculate more and more W, and that principal components is helpful now. Okay, so the point is, now we were discussing why, where we should stop, okay. So earlier what we understood, now I just draw this graph, because this graph is everywhere in the week one. Okay, so we know that these are the these are the proxies. I'm just drawing the proxies here, and one more proxy here, one more here. So the point simplified. Okay, and now, so this is x. Okay, this is x, these are the perpendicular distance x. Okay, so you will say, you will say that, okay, that's fine, because in real time the points are never be on the line, there will be some points are also on the line, it's okay, we are happy, but most of the points are also outside the line, and you have to draw the proxy, and we can maybe tolerate this much error, it's okay, we are happy with the tolerating this much error, as this is the projection and they are the minimum error, minimum distance between the point and the line, so we can tolerate that. And as per the Pythagorean theorem, so if you see this graph, this point, okay, and this, okay, so you know this is a point xi. So what is this is error. What is this error? Xi minus xi transpose. We know that, till now we just gone through that. Okay, this is what your error. Okay, and what is this point, this much, this is nothing but your xi transpose w into w, this much. Okay, this is what, this value, and this is what, this value. So as per the Pythagoras theorem, what we know that xi transpose, see, this is xi. Okay, xi transpose, this square of this, like the this square is nothing but c square is equal to a square plus b square, correct. So this is c, for example, and this is a and this is b. So c is what, xi, this distance, xi square is equal to xi minus xi transpose W into W whole square plus xi transpose W into W whole square, because this distance and this distance. Okay, I just draw. So you know that, what you know, this error should be minimum, correct? You know that this should be minimum, this part should be minimum. Okay, happy, this part should be minimum. But what is the next? So we what we did, like earlier what we understood, that you want the values here, here. So in one point we were like saying that we need something like this xi, and if I do the summation of this xi, so that summation, if I just do the I will just do summation of all this xi, because I just give you this xi value, maybe this xi, this xi, this xi, this xi, because we have to do all the summations, correct? So if I do the summation of this all the values, so what will happen? Xi square, that is summation 1 to n, okay, 1 to n, okay, you see xi, and then same way 1 to n xi minus xi square xi transpose W into W. This is what the error here, okay, this error, 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 the summation of that, okay, plus summation of I equal to 1 to n, okay, xi transpose W into W. Okay, this is what we are doing, the summation. So what we do, so simply take the average, like average means 1 by n this type, 1 by n this side, 1 by n this side, simply take the average of this. So you know that this error, this error function, this, because you want this should be smaller enough, because you are doing this summation of xi, you want this error should be small enough. But if you want to, this error should be small enough, because this is the combination of error plus this data. So if this error should be small, means this should be more, correct? This error should be small, so this should be more, because if you are just bringing this much data, if this is, if you are having this much of information, if it is having small, the next one also have to, it should be like a little big, so the summation will be become here. It is 8, if it is 2, it should be 6, if this value should be bigger enough to get this much value. So if this error is small, it should be more enough to get the final result, okay, but this should be as large as possible, this value should be as large as possible. Okay, we are very near to the PCA concept. This is actually the PCA, the concept here, just understand now. So what I did, this is xi values, these are the xi values here, these is these values. So what we did, we just used the Pythagorean theorem, and we just calculated this theorem, a square equal to c square equal to a square plus b square, means this is a residual, this residual plus this square, okay. And with that we just did the summation of everything, because we have so many points here. So we just did the summation of all the points, here, okay. And we found that the error should be minimum, because our main motto will be the error, like error means what, this proxy should be like the minimum proxy, it should be the minimum proxy here. So we are interested in reducing the error, and means we are interested in reducing the error. But by default what happened, this value but increases. If you are reducing the error, if you are saying like this, and if you just do like this, then this will increase, and this is like this will increasing if you want to reduce this error. So this way, same way, so you are increasing this highlighted portion. So that is what this is the fact, this is the actual fact what we are using in the PCA, okay. So larger the value of this, the better the fit, means if you just increase this value, if you increase, So if it is like the larger the value, means for example some line has small value, some line has bigger value. So you, because what we did, we want W should be max, which is increasing W transpose CW, correct? W this max of this equation, the W which give max of this equation is the best. So one W give this small value, one W give the bigger value. But we are now discussing with the W, means this value xi transpose W into W. So whichever the maximum value, that value is what is our interest, not the small value, not the L value, not this line. We are interested in the line which gives the maximum of this value. Okay, so if you just now, means here this value, okay, 1 by n summation of I equal to 1 to n xi transpose into W into W. Okay, but you know that like because what we did here, sorry, what we did in this equation, so it is what, sorry, it's, I should put a square here, not not the here, this is because a square plus b square, na? So Pythagoras theorem, so this should be a square. Okay, did I put here? Okay, this is also square. Okay, okay, so you want what, W square. So how you write it is actually a xi W means a, for example W is here, so is square means a square and W square together, so W square is what, 1. So you don't need to write that, so that's why if you just remove this W is also good. Okay, so this is the value. Okay, so larger the value of this, which is better the fit, larger the value of this equation, of this equation, better the line fit, better the fit. Okay, as means this, if this is more larger, is a more bigger than the other line, that is the best fit. So if you actually, now the k value will come here, so if you actually plot the graph of this one, if I just simply plot like round k, I don't know how many rounds I should do this calculation, W1 W2 W3 W4 W5, how many rounds I don't know, this round k. Okay, and another value is 1 over n summation of I equal to 1 to n xi transpose W, okay, square, because what we did, oh sorry, should okay, because as I mentioned, a into b square means a square into W square is, W square is 1, so I will get only a square. A square means this one, so no need to write W square here because W square is 1. So xi transpose W square, if I plot the graph, you know that because at the first round this value is the bigger one, because you know that the W1 is the bigger one. Okay, next time W2 will be smaller because W2 will be small, so this value is going on decreasing. If you plot the graph, actual graph, these values are decreasing. At one point this value become like, at some level this value, as we mentioned, the residual becomes 0, means there is no need to calculate W because there is no value present here. But at one point there is something like a elbow point, you can say, because you know that our hand is something like this, our hand, so this is what the elbow point, so it comes and then stops. So suddenly these points are like this, at one point this is dropping, so this is what we say for this point as a elbow point. Okay, this is the elbow point, afterwards it start decreasing. So whatever these points are there, this is what we call as a signal direction. Signal directions means the directions where you find this is the best line. Okay, this line is giving me the good idea about the feature, this human face is having this eye, this side I get eye of the human face, this side I get a face if the human is raising his hand, so this side I get a hand of the human face properly, more informations about that, so something like this. So this is called a signal direction. and these are the error directions, remaining error direction, error direction. Okay, this is the error direction and this is the signal direction. And what is this point? This point is called as K. So you have to stop at one point. Like you can simply go on, but what is the use if it is just simply giving residual equal to 0? It's not of use. So you can stop at one point, and that point is called as the K point. And you have to check every time signal direction, like here this much signal direction. So this direction, this much data, this many W's should represent 95% of your complete data. Okay, once you feel that this many W's are there, these many values are there which represent my complete, like you have this many big data, you have like thousands of points, and out of that you are just interested in 200 W's only, principal component, that you have thousands of dimensions, but you are representing only in 50 dimensions. In 50 dimensions, 50 W only you are happy with representing complete data. So 50 is your elbow point, that is the K point, that is the actual value. So signal direction divided by if your total direction, total sum, like total, if it is greater than some threshold. Okay, threshold, I should draw it properly now because this is very important point. Okay, so signal direction is nothing but here. Okay, this side of the graph, this side. Okay, means how many W's are there, like round one, first round, second round, third round, fourth round, fifth round. Round means what? W1, W2, W3, W4, W5. Okay, when I should stop at what W? Okay, signal direction divided by total sum should be greater than some threshold. Okay, and that threshold is how much? We generally in practical we consider that threshold is 95%. Okay, so out of 100, if your K, whatever the K you are getting here, the K should be give you the 95% of this this value. So you will say, what is this K? What is, because what I don't like understand what is this 95%, how to get. So what happen in exam, they will give you some kind of questions, like they give you the eigenvectors, eigenvalues. Okay, eigenvalues, and they will say that okay, you have the eigenvalues or eigenvectors, and you have to calculate all the sum of all the eigenvectors. Okay, that is total sum. You have to calculate all the sum, maybe come as a I don't know, like for example 80. Okay, okay, and out of that you have to check how many W4, or like which W calculation you can take, like till what W you will stop. Like okay, I am stopping at W number 6, instead of going till W15, I will stop W6. So total W's are 15 W's. So total sum till all W's are 80, and out of 6 you will get something like 60. So let's do that calculation. So you will get that how much is that? Okay, so it is like 75%. Okay, so this comes at 75%, but that is not sufficient. So you have to check another W. Look, take W7, W8, W3. So you have to, the questions will ask how many W's, how many W's you will take, but that W like W's are nothing but how many W's means how many eigenvectors you will consider. So you have to figure out the ratio which is greater than 95%. That is nothing but your actual value of K. So K will have some 5-6 options, and you have to like choose which is the best option. You cannot simply go with all options, like you can simply can't take one. So you have to redo the comparison also. So you have to choose which W is the best W. So how many W's should I take? So that is what now the W calculation comes. So because this is what the theoretical, but practically something which I explained. There are in exam you will get lots of eigenvectors. You have to calculate the values of that, and you have to figure out how much ratio I should maintain as 95%. So how much I should make that, sorry, it's not W that, but you should take eigenvalues, the eigenvalues like lambda values. So you have lambda values, eigenvalues, lambda 1, lambda 2, lambda 3, and these values. Okay, so you have to find out, sorry, I did W1, I should not do W1, it should be lambda 1. Okay, uh, okay, maybe I'll just draw it like this way separately, but you have lambda 1 values. Mhm. Okay, I think I'm not able to draw it. Okay, okay. I will check, but okay. But anything question anything about this one, like how why we calculated that many W's? Any questions? Uh, okay, where you left? Tell me so I can maybe. Yes, yes, yes. Ah, okay, okay. Okay, okay. So what happened? Maybe because now I just want to draw something, but I'm not showing why the pen is not drawing anything. But it's okay. So what happened? Now we did you calculated W1, W2, W3, and all so on, correct? So you did that, but how many W's you need to go? Like you can go with maybe residual becomes zero. Like you go W1, what W2? W2 is kind of a residual calculation or that error calculation. Correct, correct. So like this, but if you go at the end, what happened? It becomes zero. Correct. So we said that you don't need to go till the end value. You need to go at some level, because see, they, as I mentioned, there are some points which will immediately become zero. Like some points, like maybe you got some data set from the client, and the client given data set has complete linear combination. They are having proper linear data, like you don't know, but luckily you got that, your day was good, you got that Excel sheet, you are the data analyst, and you found that, and okay, all data are properly oriented in the first quadrant and in X direction, very much like 45-degree line. If you draw, it's very good that you can plot that. But the point is, like, next point is, you feel that okay, so then the same, if I just see that data where it is also in the another quadrant, whether it's spreaded or not, you need to also see the how much spread happen for the data. You will calculate another W2, and you will see that W2 calculation is from the error of your proxies, like residual or error from the earlier actual data. And in W2 itself, in that proxy, you saw that oh, residuals are out zero, means your most of the data is in the X direction, this side. No need to get more data in W2 direction, more data is W1 only. So you don't need to do a W2 calculation, or if you do it also, it will become zero, it's fine. Or the direction is okay, little bit information you will get, like there won't be exact zero, but you will get some information. But later on, once you go W3, you will get very minute 0.001 kind of a residual, which is like you no need to spend more time to get the W value from that residual. Yes, yes. So yes, yes, yes. But generally, practically, we don't go with 100%. If you see the graph here, what I'm highlighting, so here W1 is at this point, at the peak point. W2 will be here, W3 will be here. So you are going this way, but you don't need this kind of a error direction. Yes. So we are thinking that what k we should stop, because these are the error direction, and the signal direction is this much data, this much highlighted data. So you need that k value. 95%. 95% accuracy we should maintain. So what that W's are nothing but your principal component. But why what happen in exam? What they will do? Principal component came from eigenvalues. So you have eigenvalues like your trace. Trace is what your lambda 1 plus lambda 2 and lambda 3, and they have given you some matrix. They will say, or they have given you word that we have eigenvalues of 2 comma 3 comma minus 5 like sorry, not minus, but there are some values they have given you, okay, bunch of values. So what you have to do, you have to sum all the eigenvalues, okay, and you have to figure out the 95% of that sum is how much. Like for example, if the sum is coming at 80, so you have to find out how much is the 95% of the 80, okay. So that 95% is coming maybe how much is 70, 70 is 75 something value. For example, 80, how much is the 95% of 80? Consider 100 is consider 100, okay. It's easy to remember. If all the eigenvalues are summation is 100 and you need to achieve 95% of that, so you will just see that the summation of how many eigenvalues are there equal to 95%, correct. So you got like maybe I don't need eigenvalues are something like 20, 30, 2, 5, 6, 7, 8 like this, and you found that you don't need to take all 10 eigenvalues. You can just simply take 8 eigenvalues, and 8 eigenvalues are enough to get 95%. Or maybe if you get proper or bigger eigenvalues, you maybe end up with the 5 or 6 eigenvalues which give the summation equal to 95, okay, or more. So 95% is achieved with the 4 or 5 eigenvalues instead of 10. So k is equal to what? The number of eigenvalues you are taking. 1, 2, 3, 4. Okay, 4. 4 is the k, is nothing but your 4. So that k is what you need to consider when you are doing with the bigger optimization. So that kind of a calculation you should have in your code. In Python code you should put this kind of a calculation. You calculated eigenvectors or eigenvalues with numpy library, you calculated that, and then you do the summation of all eigenvalues, and then you find out which is the which is the group of eigenvalues which gives you the 95% sum. So that 95%, that many number of eigenvalues are nothing but your k values. So this is what the important thing of k calculation. But I did not because as I am explaining you, I did not mention whether because how I am now, because I know that this w, whatever I mentioned you, the w and all this w calculation, but we did not connect to this eigenvalue. So this the next point was something like what we know, like w is the best line one can obtain, like you know that w1 is the best line in round 1, w2 is the best line in round 2, correct. So if I am doing wd round, correct, so if I am doing wd round, did you get that w1 is the best line in the round 1, okay, from x1 x2 x3, x2 is what residual, so w2 is the best line in the round 2. So if I get wd, that is in round d. So what happened now, we are saying that okay, w and all are like now I mentioned you these are like generally 1 second, let me, why this is okay, I'm just trying to connect the pen once again. Let me save it. I hope it's saved. I don't know why it's not drawing it. Okay, two. I'm just trying to draw, but it is not allowing me to draw. Okay, let me see later on. Okay, but maybe orally I can tell you. No. Week two, because the PCA will now come. So week two is kernel PCA. Um, no. Week two is like because week two I did not start. I'm just t week week two is what week two is giving you what are the problems. Yeah, what are the problems in PCA, and then the solution on that week to give. But here we are now at the door of PCA to open that. But we already saw the PCA from outside, like what is PCA, the mean calculation, eigenvalue, eigenvector calculation. But we are now at that point where we will say that okay, this is the PCA. But we know we unofficially we know that what is it now, if you see. So see, whatever the eigenvalues or what I have mentioned you, like the formula of here we saw that the formula x C covariance matrix we saw na, so x transpose w transpose t. Okay, the formula of covariance matrix. I think I should next time, because this is something I got this pen and this document. Yeah, no problem. But I just thought, because see, yeah. I am just okay. Okay. Yeah, actually for you guys, I thought that because this is now it's 1 o'clock. I thought that I will get some free time in the afternoon with my kids, so I can go outside. So I thought to take it in the morning. So Sunday is the best, but I thought like if I do Saturday and Sunday, I can cover more for you people, or it will be a little slow. Then once the class started, na, no, we don't get more time to. That. Okay, okay, understand. I okay, okay. Okay. So maybe I will not now go next point, but this is something indirectly the researcher. Okay. Yeah. I will. Yeah, I will just do that. Yeah. Okay. Okay. Yeah. Yeah. I will maybe, yeah. I will just do, because I also thought it's too much math, and I don't want like to. But if we don't like, I thought if we don't do that. Because this the. Mm. Yeah, because I thought if I just simply give you the what sir has mentioned, na, because for us also, for me, yeah, um, because now if you afterwards the class started, if you go through the videos now, then probably you guys will like those who are new or they won't understand, they will just simply understand the formula, and that won't be. Yeah, yeah, yeah. Yeah, yeah. I'm just trying to see whether this face recognition I can show you here, because it's there available with me, and I thought let's oh two. I wait, good question. I think I will just try to. I thought I will do it tomorrow also, but mm, mm, mm. Okay, okay. Mm-hmm. Yeah, I will do. Yeah, as you mentioned, I will try to do that. Yeah, yeah. I will actually do the what you mentioned. Yeah, that's will be good. But like these points now, this MLT is more or less math, so you cannot like skip math. Mm. Yeah, yeah, yeah. Correct, 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 correct. Yeah, can you see the screen now here? Oh, okay, okay, okay. One second, huh? I think. Okay, okay, no problem. What happened? I will I thought to show you guys the uh, no problem, no problem. This is like maybe I'm going to end this, but yeah, okay. So okay, what happened? This is one. Uh, okay, and if I okay, okay, wait. Let me open the okay, because this it will take 2 minutes for me to show you the exact entire screen. If I do this, okay, I hope you guys can now see the complete screen. Correct? Can you see the screen now? Yeah. Okay, okay, okay. Okay, no problem. Say here, this is a like the face detection algorithm has this kind of a data set. Same person with a different lighting condition, you can see. Same resolution, height width is 168 by 192, same, but it has the different face, okay, lighting conditions, okay. So if I do the mean, like I mentioned, x minus you say center data. If I do the center of the data, it looks like this. I showed you different outputs, but this is one of the input. If I take and center it, so I should look like this, okay. This is mean data, and here these are the eigenvalues. So if I go with the single principal component, I will just get this person, the face like this way, okay. So if I go with the PC2 two principal component, I will see this way. If I go with the W1 W2 W3, I can see this way, and at W4, yes, yes, and see at W5 I can see this face, this guy. So you can see. Yeah, no, if I go with the more like 100 and all, I can maybe see good to face like so this is like the figure, number of principal component W1 W2, and this variance community cumulative variance, like which value of k I should stop like this, okay. So here if I see now, see here k equal to 62 I took. So now what I showed you last time is like only 5 principal component, but if I go with that 62 principal component, I can now see how many. I can see the face of that person. It's reconstructed. You got it here? Yeah, but it is not exactly the same because it is more data present here, but less data is here, because it is optimized. Whatever important, it just save that data. So it is reconstructed with the k equal to 62, means that many principal component it use. So next is something I gave the. Mm, correct, 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 correct. Correct. But generally, because for our cars and all, we don't need high resolution camera, because you are not there for just recording. You are just for detection. So your hardware don't need a high resolution. You just get that small image with less resolution, maybe small capture like. Yeah, without color also is good for car, so it will just detect, depends upon shape, whether human or not human or something like this. Okay, but this is something as I mentioned, so I gave one image of the original, like this is one original test image. I am giving like dog image, and I am saying that with how to reconstruct that. See, it is showing the person face now. What it is doing with limited principal component, if I just go with 2 3 4 5 6 7, it still show me the personal face. Maybe in the next image I can show you here. See here, test image. And if I go with a 25 principal component, I am not able to get the dog photo till 300 3000 principal component. Means I have to do more and more calculation of principal component to get this one as a dog. Most of my images are human images, whatever I trained. So these are like not trained I am using, but whatever I calculated the eigenvalue, eigenvector, these are on this maximum data of the human face. And I am happy, like okay, I can detect human of different lighting condition, but if the dog comes, his face is nothing matching with them. And it's trying to get that, like trying to regenerate, regrade the get the data. But unfortunately, most of the data, the covariance matrix, whatever you got, most of that covariance matrix has the information of the human, not the dog. So he is trying with the more and more principal component. You can see the background is little bit something like trying to get with the dog style, but he's not yet achieved that. Maybe if I go with a 6000 PCA component, sorry, principal component, then that time maybe I can get the dog, but that is huge. So that kind of outliers will be there. See, no. So what I'm saying, for example, you have too much of data in your file, okay, and you are calculating covariance matrix, correct? This is what covariance matrix, summation of xi into xi transpose, correct? Divided by that's the average you are averaging 1 by n summation of xi into xi transpose. What xi are your data. This is what one image, 168 cross 128. Correct. So in the image point of view, it is like in the actual code base, it is like one image. So we image is something like a bigger image, like 168 bars, 192. This image is 168 cross 192 image. Okay, this much is the image size, and I am having more of the human image, and now I am trying to see that, because you know what we are doing in unsupervised learning, we are getting more and more data and trying to learn from the data itself, trying to figure out what is the relation inside the data, because we don't have any labels. We are not saying he is a dog, he is a human. We are having lots of data and you are unsupervising it. You don't have label, you are just going to the data, figure out, asking the data what is your relationship between with each other. So most of the data, 95%, or like most of the data said that all we are human. Maybe there is one wrong data or outliers we can say, and the data is saying I am dog. But what is that maximum data, your covariance matrix is saying maximum is human, it's okay. So when we are projecting, when we are saying okay dog, let's see who is he, but if you do this, still your covariance matrix has maximum of human data. It is trying to get the data, but still he is saying he is human. So till 3000 principal component also is saying he is human, means maximum of data is human. So this is what the principal component analysis PCA will do. So maximum data is human data. So I thought to, yeah, no, no problem, no problem. Uh, okay, okay, okay. Because now onwards, na, because this is what I just showed you the math. Now this math is little bit like it's starting. Yeah. So this is like I just thought to show this example early, but then you guys would not understand like what is PC component and what is that R value. Then I need to explain R. But now you understood that R is like the number of principal component I am trying to get, like how many R is like. So so this is what it explains. So that's why I waited. But yeah, I will try to maybe share the screen. You guys can maybe run it into 2x and finish it in early. So that will be easy. And maybe tomorrow, yeah. Tomorrow I will mention what will be the time or if I am available and also. Okay then. Okay guys. Thanks then. Thanks. No problem. Yeah. Bye. Firoz. Yeah. Bye.